everyone. Thank you for your patience. Oh no, am I gonna lose my mic? Hold on.
Oh, is luck with me? Luck is with me. Do I risk another move? Maybe slightly. Come on. Okay.
I think we're good. I'm gonna stop messing with it. Let's see here. Hello to all of you. Strawberry Jesus, Red Hackin, Onad, Deaticus. I'm always struggling with yours. I'm sorry. Just as good Joe, Joe Fish, Third Tier Gaming. I think I got everyone so far. Remote, welcome. And Onad, you say, I missed day 5. Will I be lost today? It's been one of those days, friends. I'm trying to remember what we did yesterday. Thankfully I have my wonderful schedule right here. So yesterday we did K-means. That's right. We were looking at our first unsupervised learning model. I don't think you will be lost, Onad. I will say that tonight's stream is going to pull on a lot of the things we talked about in day 3. So decision trees and k-nearest neighbors. If folks feel good with those, I think we'll be good. If we need a small review, I can do that at the start, no problem. But tonight I should specify we're not just doing anomaly detection. We're doing anomaly detection hard mode. We're doing unsupervised anomaly detection. So it's gonna be a little more challenging than your standard anomaly detection problem. But first, as always, I want to start opening up a little bit. To start with any questions from last time. Anything that maybe occurred to you throughout the day, is clearly you spend your days thinking about the machine learning streams that we all talk about. No, but in all seriousness, a lot of times one of the experiences that I've had when taking classes is that when I've got the person teaching me in front of me, I can't think of any questions. And the second they walk away or the second the class ends, suddenly I come up with all these questions I have. And so if that's happening to you, I want to make sure at the start of each stream, we've got a little bit of time to answer any questions left over from last time. And Red Hack, you say, you're too stupid for machine learning. Why are you even watching this? No! I promise you, you are not too stupid for machine learning. Machine learning is very intuitive, right? Because essentially, the goal is to get computers to think better, but in a similar way, or at least be able to perform in a similar way to human beings. So I promise you aren't too stupid for it. If you haven't been here since day 1, I would really recommend going to the YouTube, which I know. Oh no, I'm such a failure. I completely forgot to put... Okay, hold please. And thank you for following VTS Fly. I'm making a note to myself right now. I'm sorry, friends. Please wait. Add YouTube and GitHub commands to stream overlay. Because I keep saying I'm going to do it. And then guess what? I seriously forget. So you know what? I've got it written in my messiest handwriting ever, and that is going to sit right there in front of my face. So there's no more excuses. I cannot miss out on it. But in all seriousness, Red Hackin', if you're interested in machine learning, I'd recommend starting with day 1. But we do have the notes available for day 4 onward, and we have VODs for every day, and the code. So you can catch up. Don't worry, we're only halfway through. This is day 6. We're halfway through the 12 days of Machine Learning Miss. How are you all feeling? How's it going? Are you feeling like you're starting to get a handle on all of the wonderfulness that is machine learning? And let's see, you say, seems silly question, but have you seen Boston Dynamics' new video? If that's the one that was just posted in my Discord, then yes, and it made me a little bit sad. If it's a different video, then I have no idea. I've honestly been in a whole, well, the one that I saw was Third Tier Gaming. Didn't you post it? It was this robot that was like accosting a person. So it was just, oh, no. Okay, I haven't seen that. Is the dancing one? Was that? Yes, okay, hold on. Onad posted that earlier today, and I was in the middle of getting ready for stream, so I actually haven't seen it yet. So bear with me. Collided scope. I will take a look at it either in the kind of casual part of the stream tonight or later tonight after stream. My apologies. Today was I wanted to do this stream justice because this is a topic that is near and dear to my heart. And yes, please, Te amo mucho, fork away. That was kind of strange. You are more than welcome to fork the repository. You do not need to ask. I will say that one of the caveats is that the code that I've posted is literally just the code that we've done together in stream. I have not gone through, I've not edited it yet. I haven't added notes. There will be more detailed notes coming after the stream has ended or after the series has ended. Ooh, Airborne Kingdom. Okay, Loafbone, you'll have to remember that one for me after the 12 days of machine learning miss. Then VTS Fly, you ask, is it worth watching day 1, 2, and on for people who are total beginners? Absolutely. So thank you, Bruno Skonrad, for following. I designed these 12 days of machine learning to build on each other, okay? So each day is going to build a little bit on the things that you learned the previous day. So if you haven't seen days 1 through 4 or 1 through 5, oh gosh, we're on day 6 now. Don't panic. I think that you'll still get something out of this stream. So please do stick around. But I would recommend, just for your own edification and for kind of being able to follow things as deeply as you'd like to go back and watch days 1 through 4. If the VODs are available on Twitch, I'd recommend doing that first because then you'll be able to see chat and everything. And now that there is a YouTube channel, I'm doing my best to repeat the question asked by chat before answering so that the YouTube folks they're not completely in the dark as I'm like laughing and responding to people in chat and they have no idea what's going on. So hopefully I'll get used to this juggling of YouTube and Twitch. We'll get through it together. But, and hi, Severo. Yes, you said you caught the beginning of my stream this time. Indeed, yes. So I'm glad to see that you're here for the beginning. And Hisouka, thank you for following. Okay, so anomaly detection. Like I said, this is near and dear to my heart. This is a topic that is really, really interesting, both from an astrophysics perspective, because a lot of the times the things that we're looking to detect in astronomy are anomalies of some kind. They're going to rise above the general noise of space, and noise in the data sense, obviously, not in the sound sense. 201 Batu, thank you for following. And so this is a very interesting topic. So I've got quite a bit of heft here for tonight. So bear with me. I even have like a reach goal, which is talking about something I find really, really, really cool. So if we can get through all the material and I'm not exhausted and I still have my voice, then we'll be able to dive into some stuff that I find very, very cool. And V Galvez, you say you subscribed. There's no alert. Hold, please. My alerts are working. Why? Are you sure you subscribed? It's not, Streamlabs isn't even seeing it, so it might not have gone through. I'm going to test a subscription, so one moment, folks. Yep. Subscriptions are working, so I would just make sure that it's actually going through. Or if you resubbed, it might... No, I still think I see people resub. I still think I see the, and maybe we saw it last night. Loafbone might be right. That's very strange. I will, refresh chat. Hi, Mosh. Well, I love, cats and dogs, so. And let's see, Jarude, you asked, which coding language is used for collision detection? Actually, I'm presuming that you're talking about self-driving cars or about, like, smart cars. I'm actually not sure. You could definitely do it with Python. I've seen a lot of models done for computer vision for autonomous vehicles that's done in Python, but I'm not sure specifically if all vehicles use Python for collision detection. V Galvez has redeemed Hydrate. Thank you. Cheers, my friend. All right. Let's get down to it. So one of the reasons I love anomaly detection so much is I think that it grabs and has within it a lot of the most difficult things about machine learning, a lot of the most difficult challenges, in my personal opinion. Because if you think about it, yeah, let's switch over to our blackboard so I can keep nattering on at you and still write things. All right, there we go. I have no idea why I'm all the way over here, so I'm gonna move myself. No one saw that, right? Thank you so much for following Delta Rouleau. Welcome. Okay. Let's get my little tablet here in the right place so my handwriting can be somewhat decent. And no judging. And through 2 Gaming, you say you're pretty sure it's in-house code. Well, yes, I think the question was what language was being used. Oh, lordy, why is it always around stream time that my cold starts to, like, flare up a little bit? All right. Yes, I got your name 100% correct. I'm so glad. Well, welcome. Okay. So let's see here. And then Drop Bear Antics, you say, hello, question. What is unsupervised anomaly detection? You have come at the right place. We just started. So prepare yourself, my friend, because I'm literally about to jump into it. Okay, so anomaly detection. All right, so as Drop Bear has so accurately pointed out already, is we've got the supervised versus unsupervised. Now, I might let chat take a crack at this, right? Yesterday was the first day that we started learning some unsupervised models. So can someone in chat, what should I put up here? What are the differences that we've talked about between supervised and unsupervised, unsupervised and supervised learning methods? And thank you, Triumphant Base. I always want to say bass. I'm so sorry. I don't know why. I don't even fish or anything. I love this brush. That's what I do all my titles for. Because it's just like I love all the stars. And Just As Good Joe, you say labels versus no labels. Yes. So that's the biggest difference. What else can I put up here? So this is the biggest one, is definitely in supervised learning, we have the answers, right? We have our images and we know it's cat versus dog for Mosh. You know, we have whether or not, you know, the passengers died or survived in our Titanic data set, or we know the price of something that we're trying to predict. And MC Childs, yes, unsupervised is focused on identifying trends rather than prediction. Excellent, thank you. You read my mind. I would say finding, instead of trends, I'm going to say finding patterns. Because trends are something we can definitely exploit with prediction, whereas unsupervised learning is really about finding those patterns within the data, grouping the data, finding subgroups, finding communities, finding anomalies. No. The biggest difference here then with anomaly detection is supervised versus unsupervised. So this is I would say general. These are general differences. And Drop Bear, you say, if it's like in remote sensing, supervised involves training the system with known data to help detect similar objects, whereas unsupervised is relying on rules of thumb to identify objects. That's a great way to put it, too, is that a lot of times in supervised learning, we have an explicit training phase. And while we might have fitting, or something that might be akin to training, it's not an explicit training phase. No explicit training phase. Also, please, if ever you can't read my handwriting, let me know. I will rewrite something. Can you work for NASA, Gerude? I don't know. I've been a contractor for NASA, but I've never actually worked technically for NASA. They funded some of my research, but that's about it. And then Justo, I'm just going to call you Justo if that's okay. You say, what would be better for determining whether an anomaly is a true anomaly versus statistical error? Powering the statistic or model itself, or just consistently finding that anomaly? Let's hold off on that for now, if you can hold your question. Because I want to get through, like, you're asking a later question, and I don't want to answer that and go off track and have people be like, what are all these words she's saying? Until we've defined some of our terms. And then Ian Alex Hart. Thank you for the bits. Welcome. How are you doing? It's good to see you again. And Severo, you ask, is the difference between saying trend versus patterns in this context the difference between knowing directionality, like claiming cause and effect? Yes. So in supervised learning, those trends that we're looking for, there's a relationship that we are assuming. We are looking for causality, or at the very least, a kind of relationship between our independent and dependent variables. Whereas in unsupervised learning, that relationship might exist, but that's not really what we're looking for. We're specifically looking for patterns and relationships within groups of data. And MPRXYZ, thank you for following. And Severo, thank you for the bits. So Malasteph, you say no explicit training phase isn't really true. It really depends on the model. Like I said, there's something akin to a training phase, but it looks a little bit different than it does in supervised learning. So there's going to be training differences. Also, it helps if I spell training right. What happened there? I must have been talking. All right. There we go. Go to, oh my goodness. Go to Dopalhacko. I butchered that. I really struggle when there's no spaces between words. Thank you for following, regardless of what your username is. I'm so sorry, I butchered that. Okay, so explicitly for anomaly detection. Oh no, I left this big. Okay. Supervised anomaly detection can look like a couple of things. You might have a data set with labeled anomalies that you're going to train on. Oh, gracious. Might look like that. Or you might want to find inconsistencies. How am I doing here? I'm gonna scroll down just a smidge. Doop. All right. Or, you might not have labeled anomalies, but you at least have the thing you're trying to predict, and you're trying to look for edge cases. So you might be looking for, like in our Titanic data set, who survived that's like completely different from the other survivors. So you might be looking for, how to phrase this? You might be looking for groups within the labels. To find outliers. And V. Galvez will talk about defining anomaly in a moment. Well, in unsupervised anomaly detection, we are not going to have a lot of times the labels that will show us what is anomalous and what isn't. So in some ways we have to, in this case, I guess the equivalent of the unsupervised version of this is we have to define anomaly. And we're still looking for groups, but we won't have those. It might be that we treat our label, if we had labels, we would just treat it like another feature. So the other big difference is a lot of times in unsupervised anomaly detection, our data is going to be it's going to be highly unstructured. Not always. So don't take these as like I'm saying, every single time it's like this. But a lot of times, unsupervised machine learning in general, but also specifically for anomaly detection, is dealing with these really difficult cases where we have highly unstructured data that is often, I'll say, noisy. And so it's going to be really, really challenging. But why? Okay, so you might be asking, well, why do anomaly detection then?
Why do we care?
And I always like to have this be an important part of asking ourselves, why are we even learning this? So why anomaly detection? Well, there are lots of, let's switch up our colors. Have you used purple yet? No. Okay. So why do anomaly detection? This sounds already kind of nightmarish, right? So you might think of examples. That's very thick. Okay. I mean, and please in chat, tell me if you have an example of something that you think anomaly detection could be used for. But here's some examples that I'll give you. Finding planets around stars. And thank you so much for the bits, Ian Alex Hart. Let's keep a tally of the treats that we're gonna give the pups. Hubble has been dosed still with some medicine right now. He's doing a little bit better. He was able to kind of like run around the yard a little bit today, but we did just kind of get him to sleep, and he's got to stay off his paw for just like a little bit. So if you can hold on and bear with me, I promise your bits will be redeemed as treats for the boys. I just want to give him a little bit more time to sleep because the Benadryl kicked in and he's passed out. So he's got to stay off the paw. If he gets on it, he could tear it again. So I'd like to give it time to just heal a little bit longer, let him sleep, and we'll give him some treats. And V Galvez, you say, not having labels makes life more difficult. There's no ground truth for evaluating your model performance. Exactly, we're lacking ground truth. That's a great way to put it. And Delta Rouleau, you say, so it is easier to get unlabeled data. I would say that, and Hagask, thank you for following. Not necessarily, I would say it's harder to maybe deal with models in the unsupervised space, but that often data will be, like real world data will be unsupervised a lot of times. Amongst other things, a lot of times real world data is unstructured, it's sparse, it's lacking, there's lots of missing features. A lot of times your data sets might be small. So there's a lot of different challenges. I will say that at least in my experience, building machine learning models off real world data, that data is most often unsupervised. It's lacking those labels. So it's really about trying to figure out what relationships and what things we can exploit without having the labels. And so let's see. And Severy, you say, I also was really wondering why we're covering anomalies. I thought ML was supposed to help us see patterns in our world, not pick out the odd stuff. Well, I'm so glad you're here then. Acromonic, you say in security. Yes, cybersecurity is definitely, or even just security in general. So fraud detection. And so for cybersecurity, think you're trying to find unusual events. Unusual here, meaning that we're making an assumption that unusual might be hostile. Is my head covering that up? No, okay. Fraud detection, also think kind of another similar thing here is detecting activity like on your credit cards. So if people are trying to identify like theft detection, unusual financial activity. And let's see, identifying important genes in a network governing a disease. That is so far beyond me, but I will trust that there are some interesting medical applications as well. Sideways 42, thank you for following. And Dark 4RC, you say, anomalies are inherently another pattern you want to detect. Why would you want to treat them specially instead of having the primary pattern recognition pick up the lack of recurrence when modeling? That is such a good question, and I wish you could see my notes right now because that's a point that I wanted to talk about. Because you are right in a sense. One of the things that we can do, one approach to anomaly detection is a little bit different than what you're talking about, but we fit a model to what we consider normal, and we look for where the model fails, where the predictions are really, really wrong, or where the model just doesn't fit as well. And that is one approach to anomaly detection. But I think one thing that I want you to remember, just kind of picking off the way that you phrased that, is that there are some assumptions in anomaly detection. Oh no. Okay, and so give me one sec here, and I will get to what I'm talking about. So, as we've learned all these different kinds of models and data types and whatnot, we've been talking a lot about the assumptions that models might make. We've got a couple assumptions that are often very common in anomaly detection. And thank you, JP Monetus and Fenrir Willow, for following. One of those assumptions that's very common is that the anomalies, let me actually phrase this a slightly different way. The incidence of anomalies is less than, I guess I think I need to mean prevalence here, but whatever. The incidence of normal data or normal events. So to get to your point, Dark 4RC, if anomalies and normal events were equally as prevalent, I should probably rewrite this as prevalence and be very specific. I had some epidemiologists this summer correct me that those are not the same thing, and I desperately learned the difference. That doesn't look right. Prevalence? Prevalent. Oh god, someone help me. I think that's right. I'm usually quite good at spelling. Help me out if that's wrong. But the prevalence of anomalies is less than the prevalence of normal events. And so if they were equally as prevalent, then we could fit a model to detect the anomalies quite easily. They're just another pattern. But anomalies are a little bit special because they're often, this is what we're talking about if you hear anomalies described as rare. They're often not going to occur as frequently as the normal events. Similarly, they are going to often occur in noisy data. And why I say noisy data here is if we look really, really quickly back here, apart from the planets around stars, which will be noisy as well as a function of the instrumentation and also the fact that stars are just annoyingly variable sometimes. Cybersecurity, fraud detection, theft detection. All of these things are about identifying anomalous patterns of human behavior. Humans are weird, all right? Seriously, humans are bizarre. Our behavior on any good day is actually way more variable than you think. So identifying anomalies in human behavior is really hard. So for example, cybersecurity data. I used this example in a previous stream, but just because I go to a website I've never been to before does not mean I'm doing something wrong. Just because it's something that's never happened before, just because it's a topic I've never looked up before, doesn't mean that I'm doing something hostile. Or I'm doing something inappropriate. And so that human beings, we constantly are expanding our behavior. We have variances in our behavior that are rather large. And so it can be difficult when doing anomaly detection with human behavior. And thank you, Captain McNoob, for following. Okay, so let's see. The other actually example that I wanted to do back here, before I forgot, is that anomaly detection can be very, very useful in pre-processing. So even if we're not, even if it isn't the end goal, we might be looking to prune problematic outliers from our data before moving on with a different model or with a different kind of, a different approach. So anomaly detection can also be used as a pre-processing step. So one thing chat didn't get, it's okay, chat. I love you all still. Okay. So we've talked about how the data is often noisy, it's unstructured, anomalies are often rare. The other problem that we have talked about briefly in some of our other streams, remember when we learned about bootstrap sampling, for example? Sampling becomes problematic when you're doing anomaly detection, and here's why. Sampling is complicated. And we're going to test my drawing ability here a little bit, so bear with me. All right, so here's our feature space. Remember, we're not afraid of that word anymore. It's not a scary word. It just means the frickin' space defined by our features. We learned that yesterday. Augusto Angelum, thank you for following. All right. Gotta think about how to draw this. This is the hardest thing, because it used to be I could just make a scatter plot, right? And try to be random. But now I've got to, like, give the data a certain pattern that looks a certain way sometimes. So let's just draw some points, and we'll go from there. And Dear Rude, thank you for following. Okay. Some weird ass anomalies. All right. Hello from Brazil. Well, thank you. Hello. I'm doing my best here, Delta Rulo, to make data. All right. So let's say for just the sake of argument, this is an anomaly. I'm going to say this is an anomaly. We're going to say that's an anomaly. And we're going to say this is an anomaly. Maybe this one too. All right. If I'm randomly sampling my data, I want a different color. If I'm randomly sampling my data and I'm like, you know what, data, it's fine, we're going to shuffle it up and we're going to just sample it. So maybe my first sample looks like this. Well, that's fine. It would probably identify this as an anomaly, no problem. But what if my next sample of see, this is the hard part of drawing. Like, I am being prescriptive here, but intentionally so. Okay, so let's say my next is this. Well, this might incorrectly think that this point here is an anomaly because it's so different from the other ones, the other group in this particular sample. It might correctly identify these two, but it might think this one's an anomaly. Essentially what I'm getting at is that based on the sample that we've taken, even if that sample is random, it can cause some data points to look like anomalies when they're not, or it can cause some anomalies to look normal. And so we have to be very, very careful about what sampling approaches we take when we're doing anomaly detection. Which brings me to an excellent point that someone asked earlier, which is what is an anomaly? I want to open this up a little bit to chat though. How would you define an anomaly? And it's okay to define it as subjective, as non-mathematical as you want. Oh my goodness, Ian Alex Hart, thank you so much for gifting a sub to Railbird80. Welcome, Railbird80. I think we've seen you around for a bit, so I'm so glad that you're a subscriber now. So Onad, you say a random occurrence. What about it being random? Like if we had a truly random distribution of data, which this is not going to be truly random because I'm going to suck at it, but that's fine. Is anything really anomalous in a truly random distribution? Like maybe our edge cases, but I don't think it's randomness that makes something anomalous inherently. So let's think about some other ways that we could possibly look at anomalies. And Alex73630, thank you for following, and Nico CS, thank you for following. Anomaly is what they try to solve on House MD, Nico. I like that. I like that. It's a good way to think about it, right? Because it kind of feeds right into what Drop Air Antics is saying is an anomaly, something that isn't noise. So it is not noise, but can't be explained by our current understanding. Okay. What else, chat? Structurally different from the rest of the data. Distinct. I like that. Different. Distinct. Oh, Finks, if you say everything's an anomaly, like, we are headed down a tough road, my friend. Outside a standard. I like that. An outlier. Yes, I like that. It's simply MG. An outlier. Out of the ordinary. Looks like something, but we're not sure about it. Okay. And Herr Ermel, welcome. Thank you for following. Data is my drug. You say if it's a weak distribution, you could possibly find an anomaly of seemingly random points based on a portion of the data points showing some pattern. Right, but we're really looking for a meaningful anomaly. So all of this, when we think about our feature space now, thinking about all of these different ways that we've described it. It's not noise, it can't be explained, it's different, it's distinct, it's outside, it's an outlier. What are these getting at? Like let's turn to math for a second then. We've kind of descriptively, outlined what we think an anomaly is. Now let's think about our feature space. How would we find an anomaly in our feature space? And uno, dos, three. Thank you for following. Had to take a second and think about where the Oh, just as good, Joe. You're always lockstep. I love it. You go right where I hope someone goes. It's great. Alrighty. These are getting at distance, maybe. What else? There's a couple other ways. We're going to talk about a bunch of different ways that anomalies can be defined. So don't worry if you're completely lost at this point or you can't come up with something. Don't worry, we're going to go through different techniques and how they define distance or how they define an anomalousness. But I want to see off the top of all of your heads what you think anomalousness might look like in a graph outside of the bell curve, because here's a hint, by the way. I'll give you a little bit of a hint. Far from clusters. Okay, thanks. Yep, that's getting back to that. All right, I'm trying my best to make this kind of even. Where's the anomaly in this image? In this data? Is it that it's so distant from other points? Is that really what it is? Is it off? No? What's different in this one? And, data's my drug. You say, what are we running this algorithm on exactly? We haven't talked about, we're just learning about anomaly detection generally. We're learning about the conceptual ideas and the approaches first. We will do, we'll do the nitty-gritty details in a moment. Yes! Just as good, Joe! I really wish I had, it could just be here's a gift! Yes. Density. Which is getting back to that idea of patterns, right? So we could also talk about, oh God. Oh my God, no, we're doing this over again. Oof, that was a rough plot. If we have, and thank you, Agad, for following. I'm trying to think of something that might be like a light curve in astronomy. It's not a density, and it's not necessarily a distance. It's also just a different pattern. Something is not normal, right? Out of tolerance measurement in the manufacturing process. That's a really cool way of thinking of it, Alex73630. But so this is a really good thought
experiment to start to try to wrap your head around how, while we have an intuitive feeling for what an anomaly is, when we try to start to quantify it, when we start to try to put rules around it, it gets really, really difficult. And that is why there absolutely can be non-machine learning approaches to anomaly detection, but the challenge is that you have to exhaustively enumerate all of the possible rules to catch things that are outside of the norm. And this actually is a problem in cybersecurity. How do you predict the attack vector that comes from something that you've never seen before? How do you describe the thing you've never seen? How do you predict it? How do you anticipate it? So if we have a rules-based approach to anomaly detection, we might fail to catch the completely unknown element, the thing that we aren't anticipating. So why we should, as much as possible, remove some of that prescriptiveness so that we're not sitting here having to define, where all these boundaries are for anomalousness. We should instead have something that is able to kind of have that big picture and not follow rules. And if you're thinking back to the AI graph that or the chart, I guess, that I've drawn at the beginning of streams, that should lead you right to machine learning. We want to move away from the rules-based AI and use a machine learning approach. And Brasilia 101, thank you for following. Okay, so let's see here. Yes, I've talked about sampling. I've talked about how tough it is and terrible and it's difficult. And so what do we want ideally from an anomaly detection algorithm? Let's say we had the most amazing anomaly detection. What would we want our outputs to be? We'll say ideally. We need some way, we need to quantify anomalousness. Anomalousness, there we go. We need to quantify it in some way, right? We need to be able to measure it. We need to have a definition for what an anomaly is and how anomalous something is. If we just have a, binary kind of output of yes, no, it's an anomaly, no, it's not an anomaly. We just lost our music. Hold, please. That's less useful for us because, there we go. Got to keep our holiday spirit going.
It's less useful because it's less explainable. We really want, ideally, something that's going to tell us how much of an anomaly this is. And because anomaly is subjective, right? We're talking distance, density, patterns. These are things that we can define thresholds for. So we need to be able to quantify it. And to get to what you're saying, probability, we need a measure of confidence. How certain are we that this is actually an anomaly, right? Ideally, these two things together would allow us to make the most informed decision about whether or not this really is an anomaly, and if so, what we should do about it.
And see, you say data is my drug. Compare it to known tested models of the same thing. Well, we're in unsupervised land, so known tested models might not exist. We're not really going to have training data. And Mirror Bick, thank you for following. Okay, and there's a variety. There's so many different approaches. If this is really fascinating to you, and Kriegersaurus Rex, welcome. Thank you for following. I would these are some things we're not going to be talking about tonight, but that I would recommend looking up. There are neural net methods. We haven't gotten to neural nets yet, so I didn't want to touch on that tonight. But you can also look up support vector machines. I've seen those used. Oh, that's not how you spell machine, Jess. We're going to talk about you can use clustering. We did some k-means yesterday, so I think you can very easily see how that's expanded. And I started to read about this. I haven't used them myself, but self-organizing maps. It's another way that you can do it. These are all different wonderful ways to do anomaly detection.
And let's see.
Yeah, variational autoencoders. I did not want to. I'll put neural nets here. I'll spell that out for people. We haven't touched on those, so I didn't want to talk about neural net enabled approaches. And so thanks, you're skipping ahead a little bit because we're going to do an isolation forest tonight, actually. That's the first way that we're gonna talk about. And MC Childs, I would imagine that in combination with a quantified measure of anomalousness, we'd also want to see the basis of considering something an anomaly. Yes. And so I'll put that as like a 1A, right? Is we need to understand what the definition of anomaly is for this particular approach. Like wanting to add all these extra letters today. And how do we know if unsupervised learning is working correctly without a proven test model, sample model? Well, eventually things will be tested. And Delta Rulo, that's one of the reasons that, especially with unsupervised learning, I much prefer what's called a human in the loop approach. And so this is where before any decisions are made on an anomalous event or anomalous identification, it's passed to a human being for verification. And that's where we get to kind of a semi-supervised situation where you start out unsupervised, but you're able to pass things to a human for verification, thereby getting some labels, some confirmation that things are wrong or right. But we'll see how unsupervised machine learning, especially tonight, can be very difficult because of some of the subjectivity. And Dark4RC, thank you for following. Okay, I'm trying to avoid having to blow my nose or cough. Oh, this cold will go away, I swear, someday. All right, so let's see. Alrighty. So now let's talk about the first model that we're going to build tonight. It's kind of cool, and I think it builds off some of the stuff that we've already been doing. So first, we need to be able to remember how we do decision trees. So how are folks feeling with decision trees? We've done decision trees and random forests now on our ensembling day. So how are folks feeling with their decision trees? Are you still feeling kind of, is it really rusty? It's been a couple days, or are you like, yeah, I understand this, it's intuitive? And Sumpin and MelG1, thank you for following. Actually, hold please. I'm gonna mute myself and blow my nose while you're all telling me how much you love decision trees. Thank you. Let's see. Oh no, that was the same alert. Well, doubly welcome, Sumpin. There you go, and I spared you the gross blowing nose sounds. See, I'm so nice. Delta Rulo, you say decision trees you're good on. Oh9, you say the math or the basic idea of it. Don't worry so much about the entropy or like the Gini index and things like that. Just the basic ideas. We're going to be doing a similar approach tonight. Do I build an isolation forest? I do. Good job, me. All right. So, those of you who also have been around for a few streams now, what is the forest hinting at? What do you think the forest is hinting at for you? The decision trees among your dearest friends. I know. Decision trees are such a intuitive, explainable model. It's a great place to start for a lot of people with machine learning. Yay! Ian Alex Hart, thank you for the bits. The dogs will definitely appreciate it. We'll just have to like give them a pile of treats. Like not even the Furbo. We'll just like give them a scoop. Yes, just as good, Joe. And Strawberry Jesus. That's right. We're going to be talking about an ensemble of models. And V. Galvez, it just came through. Now it's coming through. Thank you so much for resubscribing. A 2-month streak. Thank you 1,000,000% for your support of this stream. It's wonderfully, wonderfully welcome. And so Acromonic, yes, it's going to be a collection of not decision trees. Well, yes, decision trees with a bit of a twist. Okay, so not the decision trees we necessarily learned before. But let's just call them a collection of trees, right? Which is just what a forest is. Okay. So, just like I was talking about earlier, one approach to anomaly detection is, thank you, Einstein. I appreciate it. Do you see my nice Star Trek pin? This is the This is my substitute for a suit jacket that I like to wear to work. So, oh, thank you, V. Galvez. Well, you know what? I have such wonderful subscribers and people who donate, so I would much prefer to teach machine learning on Twitch and YouTube and stuff like that, where it's available to everyone. Because the second that I start to charge for it, that creates a barrier to learning. And I think most of my life's work at this point, honestly, has been about removing barriers to learning. So I don't want to create more barriers for people. If people are able to support the stream, that's very, very, very appreciated. Definitely helps me take time and put more effort into stream and get more, tools and things like that. But I think the hardest thing is that there is, at least in the United States, such a high financial barrier for education, and I don't like it. So this stream is anti-barriers. Thank you for the cheer. Apparently that's a hype train. Can you cause a hype train with cheers? I'm so, somehow still a noob to Twitch somehow. You can use bits. Oh! Well, today I learned. Thank you so much, all of you. Oh my god, and then there's Loaf Phone, naturally. Loaf Phone, you are just giving Twitch money, Main Village, yes! Hi, Main Village and Dudeman. Now you all, an Anarchy user, ECAC81 and Oh Big Nose. I'm so glad you all have subscriptions now. Hi, Main Village, though I see you lurking there now. I got your text. I will respond. I promise. I'm so bad. Poor Main Village texts me, and it's 3 or 4 days later, and then I'm like, oh shit, I'm a bad human. I'm really bad at responding to texts. So thank you, Main Village, for your patience, and now you're subscribed. Oh my goodness, Ian Alex Hart, 10 treats for dogs, 1,000 bits. Thank you. Oh my goodness, and that there's all these things happening in my Streamlabs. I think now the hype train has lots of letters in it. I think that's a good thing. Woohoo! Yes? Level 2 complete. Oh my goodness. This is cool. I'm leveling up. The video gamer in me is like, yes, must level up. And Mets, you bet. Thank you for following. Those dogs are going to be 10 pounds overweight if I'm not careful. Gonna have to get some healthy treats. Gonna have to bake some sweet potatoes for them. Okay, so yes, Forrest is ensembling. Right, and what I was talking about, yes, Vigalvez, I will hydrate. Okay, what I was talking about is that one approach to anomaly detection is to model normal behavior and look for where the model doesn't fit. Well, guess what? That's not what we're doing. That's one way you can do it, but isolation forests say, nah. How does this hype train work? I see Yogi, I think so. People do wonderful things for streams, so they subscribe, or they gift subs, or they use bits, and it's an excitement. It's a measure of excitement for how excited people are about the stream, is my understanding of it. And if the hype train reaches certain levels, you have a countdown. It is slowly cooling off, I guess. And if people keep doing things that feed the hype train, eventually everyone gets emotes. Am I finally a Twitch professional? Did I understand that? Yes, I think I did. PogChamp. Yes? Poggers? Oh god, I'm gonna stop. I don't know what I'm doing. All right. In any case, I am trying, friends. I really am. There's just, I'm old or something. I don't know. All right. So, Pog you? What the hell is a Pog you? Oh, I'm not cool enough for this. All right. Isolation forests are doing it different. All right. The approach here, okay, is that instead of trying to model our average or our normal behavior and find things that don't fit, instead, we're going to try the approach. Let's see. The approach is to isolate. It's in the word. Isolate our anomalies instead. You still think we need to get Dr. House in here? I love, okay, so House Seriously. Loaf Bone, stop that. Stop gifting things. You goof. You need to get it to 69. Where? Oh, the percent? Are you trying to get the hype train percent to 69 because you're like a child? You goof. Oh no, you're looking for your gifting. Now you have to stop. Now you can't gift anything for a while. Oh my god. So, Nico, you ask, or no, Delta Rulo, you say you're new to Twitch for real. What can you do to help the hype train? Hype trains are helped with subscriptions, bits, or gift subscriptions. Don't worry about it if you can't help the hype train. You all are welcome. Hypes are wonderful. No low phone. Oh my god, stop using. Like you're using our stream funds to gift things to the stream, but Twitch takes a cut, so it's just giving Twitch money. Like, I'm glad you're at 69. You can pause for a little bit. No more subs for you. You're cut off. The bartender's cutting you off from the subs. And Shallotted, thank you so much for following. Okay, thank you for explaining what PogU is, Aldu. I do not see the emotes, so I must not have that extension. All right. Back to machine learning, my friends. And thank you so much, everyone, for getting us to a level 4 hype train. That's pretty awesome. I think level 5 is the max, right? Ish. But anyway, in any case, thank you so much. I appreciate it greatly. Okay. So we're going to isolate our anomalies instead. And like I said earlier, it is a type of decision tree. But like with every model, we're going to make some assumptions. We have to, right? Every single model, we have to make some assumptions so we can put constraints on what we're dealing with. Okay? So our assumptions in this case are we're gonna continue the assumption from earlier. I really want to change colors. All right, which is that our anomalies are going to be few or rare. Okay. Thank you, Mrs. Q. So you say, are you writing with your mouse or a touchpad thingy? So poor stream, when we did our stream on deriving special relativity, stream had to deal with my mouse handwriting and it was tragic. And so I did, thanks to wonderful stream donations, these are the kinds of things that your wonderful donations and subs help with. I was able to buy a tablet or touchpad tablet type thing. And so I'm able to write with this now, and you all get much better quality handwriting. It's still taking some I think I'm getting better used to it. The first day was a little bit tough because I'm used to looking where I write. And so it's a bit counterintuitive because I have to look at the screen and write. MC Childs, thank you for continuing the gift sub that you got. I know Holy Moly Mo came in and dropped a bunch of subs. They are wonderful. Can we give a shout out to Holy Moly Mo? Because that was a pretty cool, there's a Twitch clip of it. Surprised the hell out of me. They came in and dropped 25 subs. It was incredible. So, and Loafbone, you say you're impressed with how I look at the screen when I write. You would struggle with that. I still struggle with it. I think it's just, I pretend it's like a video game. So I'm kind of used to giving input to my computer in some way that I don't look at and seeing reactions on screen. So I just am thinking of it like that. So I can't tell you how many times I accidentally looked down. I'm like, no, look at the screen. So it's just takes a bit of practice. In any case, our other assumptions are going to be that the features, all right, so in this case, our data, right, is going to look different. So we're going to have features are significantly, and I'm using this word in the statistical sense, are significantly different from normal data. Okay, and our other assumption is going to be that because of 1 and 2, so this is really premise, therefore 3, anomalies will be easier to separate. Okay. So, how do we do this? How do we build an isolation forest? Well, it's going to require some really ugly drawings from me. So please stay with me. We're going to get through this next section together. I practiced before stream, I'll tell you that. I think, I don't think I have a headset command. I have like a specs for the computer and my keyboard, but my headset are the Bose Quiet Comfort. Loafbone had it last time. Oh, look, we got emotes. What emote did I get? I got hype gems. Yeah, look at that. It's got like some creepy smile and some diamonds for eyes. All right. So I did practice, so no matter how ugly this next section is, can you add that as a headset command, Loafbone and Nightbot? Thank you. No matter how ugly these drawings are going to be, please know I did practice for you. I tried, all right? Holy crap, that's expensive. They were a gift. Jesus, all right. Yes, these were a gift. Goodness, all right. Well, I'm spoiled sometimes. All right. So the isolation forest. What is the model of the tablet? XP Pen something or other. XP Pen. It's whatever one's about, like, it's about $70. Process. You can probably just look in our Amazon. Okay. What's the process? So here's our how-to, all right? You can't make the command without the model. Well, hold please, chat. Orders. All right, well, Amazon's being a butt face right now, and I'm in the middle of streaming, so I will look at it later. But it is an XP pen. It's from my Amazon. No. Fine. Hold on. Sign in. What's my email? I think my email is this. What happened to my music? Don't you stop that, YouTube. Keep the holiday cheer. None of that BS. All right. Orders. I have things in my cart. Are these Christmas presents I forgot to order? Am I a terrible human being? Probably. Where is my tablet? Christmas present. Sorry, I've got to scroll a little bit because it was the holiday season here. It is the XP Pen Deco 01 V2. That. Yeah, it's $70 exactly. And this was a wonderful gift from Stream. I love you all. Thank you. It was so wonderful. This was such a wonderful gift. So thank you, Stream. Mwah! You all are wonderful. Okay, back to isolation forest. And I'm gonna draw this, but first let's write out our process. So the first thing is we're gonna select a random data point. If I need to, we'll call it X. Super creative, I know. It's 20% off right now. Well, you know what? If I boost that, Amazon should give me like a link so I can, if I'm giving them sales, sponsored, I know, right? I don't even know how people go about getting sponsorships, but we have grown. We are, you know what? I think we are a mighty stream now, but I've been a small stream for so long that I'm just like, ain't happening. All right. So then we're also going to choose a random feature of that data point. And for those of you like, oh, features, data points, remember that a data point here is just a combination of feature values, right? So our feature, X in this case, is really like, X0, X1. Oh God, I can't write. X2, right? And so we're just picking one of these features, all right? Once we pick our random feature, we are going to pick a value between, I guess we'll
I'm not going to give feature variable, between the min value of the feature and the max value of the feature. And I know if I've already lost you, stay with me. I promise it will make sense when I draw the picture. Okay. If our data point's value is above whatever value we picked here, we're going to set our new minimum to be equal to the value that we picked. Maybe I should have picked this. We'll say the value here is V. Our minimum value is V. Similarly, if our data point's value is below, set the max to V. Okay, then we're going to repeat 2 through 3 until we have isolated that feature. So until our point is isolated. And again, I promise, I remember the first time I learned this and I was like, this doesn't make sense. And then I saw a picture, I was like, oh, what if you have thousands of features? Then this shit takes a really long time. This is why we have a computer do it. And then we count the number of iterations, and that's going to give us something called our isolation number. All right. So I'm going to do something really quick. Please wait, friends. I have a little present for you. I'm going to show you. Here's a graphic that I got explaining it a little bit off the interwebs. I myself am going to be right back. I'm going to leave this up. I'll leave the music up. I'm just going to, turn off my camera briefly so I can grab something. Think about, actually, let's see if I can have the picture and the steps. Okay, and when I come back, we'll walk through it step by step. No. I am so bad at Windows. Jesus fucking Christ. All right. All right. I will be right back, all right? So take a look at this. See if you can start to wrap your head around this process. If not, also don't panic. I will walk you through step by step, okay? And thank you so much, H. Canales MX, and Messing With You for following. I'm just going to grab a little bit of cold medicine. I will be right back.
All right. Hopefully I like coughed a whole bunch, and hopefully that will kick in shortly, and I'll stop sniffling and whatnot. All right. So hot sauce. Are we talking about hot sauce? Yes. Strophium makes amazing hot sauce. So those of you who don't know in chat, did we put the Strophium chat or the Strophium command in chat? I don't have my PhD Quibitronic. Okay, so hopefully looking at this image at least has given you a little bit of an idea of what we're about to do. If not, if it made no sense, you're like, I'm still lost, have no fear, I've been there as well. So let's do it together. First, we're gonna need a graph. So yes, we've entered the portion where I have to draw a lot. So bear with me. Well, I've published papers in astrophysics journals, my friends, so academia disagrees. All right, so this is our feature space, and let's make some data points. Sorry, I don't know why that one's a little bit hefty. We're gonna make ourselves we're gonna make our lives easy. We're gonna give ourselves a very prominent anomaly here. All right. There we go. Well, not anomaly. Let's just say that this is our chosen data point. Let's move it a little bit closer. Put it here. All right. So we're looking over our process here. Number one, select a random data point. Check. We're gonna pick this data point. This is gonna be our X, okay? And you said, could you sort the data points by feature? And if the extremes per feature set overlaps, it would be the same effect. If the extremes per feature set overlap. Sort the data points by each feature. And if the extremes per feature set overlap, it would be the same effect. No, because that would, if I'm thinking of what you're describing, I believe that would eliminate inter-cluster anomalies, if that makes sense. If I'm understanding what you're asking. Oh, we need more galaxy pen. I'm sorry. Okay, all right. So this is the visualizing. Oh boy. Visualizing isolation for us. Okay. Oh no! Okay, all right. Love Bone's drunk with power. Look out! Okay. So we're gonna say that for the sake of argument, this is going to be feature, we'll call it A, all right? And then let's use a different color. This will be feature B, all right? And let's say that they have a range currently from 0 to n to like a sub n, essentially. And from 0, well, this is like a naught, from b naught to b sub n. Okay? Timo mucho. Oh, te amo mucho. See? I can't with the separation. At least te amo mucho has the underscores. So it helps me. Okay, now we need a color for dividing things. Our dividing color is going to be orange. All right. So we're gonna pick a random feature. All right, chat, A or B, go. First person to answer, you have picked our feature. Go, 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 chat, A or B, A or B. B, wow, everyone's here for B. Damn, this is like universal. Casado Conillos says C, no. Rest in peace, A, no one loves you. All right. All right, so what is our process say? We've picked our random feature, check. Now we pick a value between min feature and max feature. Okay. So our min here is B0. Our max is Bn. So this is iteration. Oh God, why is this is chonky boy. All right. This is iteration number 1. So we are going to pick a random between b sub 0 and b sub n. Let's just say we pick b4. All right, let's say b4 is here. Now, is our x b value here, is it above or below the line? It's above. So what do we do? Is below, aka less than. So now our new b min now equals b4. So we've essentially, if you want to think about it like this, we've ruled out, oh God, here comes the bad drawings. Please don't hate me. We've ruled out this segment. We're like, nope, the data point's not here. Okay? Awesome. All right, chat. A or B? Let's go again. A or B? Gives me an excuse to keep having something in my throat. All right. A. All right. Well, Nico, I couldn't see. Actually, did you say that A or B? Let's see. We've got A. All right. Looks like more values for A. Okay, so we're going to pick a random value. So now we are doing A, so we should be in teal. Hello. All right. So now we're going to say maybe A 20. Okay? If A20 is here, well, X sub A is less than that. Is less than it. So in this case, X is not below this. Nobody corrected me. You all. You goofs. I make mistakes and everyone's like, she's right. Yes, is above here. It's greater here. X sub A is below. It's less than. And so our new A max is A20. So now we've ruled out this. Okay. The green feature, yes, the green data point was randomly picked, all right? So A or B, chat? A or B? At a certain point, I'll take over and I'll decide, but I'm going to let you all decide for a little bit. B max is not B4. B min is B4. Nope. So we're raising the bar. Our range of B values that we're able to search is now B4 to Bn. Our new A max is A20. Oh, we're evenly split. Somebody break the tie here. AB, AB. The min and max values we're choosing here are notional. They're not. So they're literally the max and min values of the feature. Okay, people. All right, well, A has one. All right, so we're going to do another A. There we go. Whew, good gracious. All right. All right, so now we're going to pick another A. Let's say we pick A7, and let's say A7 is here. Okay, I know that's not straight. Y'all are going to bear with me. And X is above this. So our new A min is A7. So our new range that we can search for A values is A7 to A20, and our range for B values is B4, okay? And we're gonna continue this process. And Go West 101 and JDog HS, thank you for following. So if we were to continue this a little bit, I'm not doing these in order. Actually, I think that last one's unnecessary, right? Yep, okay. Eventually, we get something like this. And however many times this took, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So eventually we hit 10. 10 iterations. It's going to take a lot longer than that. This is the happy example, is A20 greater than XA? Yes, it is greater. What I'm saying is A is below, XA is below, it is less than A20. So I can be more explicit. So if these less than and greater than and the below and stuff is confusing, I'll write it more explicitly. So here, X sub A is less than A20. If that makes sense. But if I'm getting this wrong again, please correct me because I did goof the first one and I apologize. So in this case, we've slowly, and this should remind you of like a binary search or a binary tree, we're slowly closing in on our data point and eventually we get there. You might be like, okay, well, tree, what? How is this a tree? Think about it kind of like this, is that, oh God, more drawing. Thank you so much for the bits, Ian Alex Hart. Yay, little pups. Did you know, I believe you are a subscriber, Ian Alex Hart. Did you know that there's a Tennessee emote? Way cuter than whatever the Franken dog is, or whatever that dog's called. What is it called? Franker Z. There we go. Tennessee's cuter. What if you land right on the feature? Like, if you guess the exact value of the feature? It's a really good question, actually. I'm not sure that's ever happened. So I would imagine you might pick, like, you could avoid that by, like, maybe only picking, like fractional or integer values or something of the whole thing, kind of like I did with, like, the x sub n, x sub 4. Let me think about that one. I'll get back to you, actually, because that's a really interesting question. But so if we were to turn this to a tree, we would have, like, you know, our first split was, what did we pick? We picked B. Oh, no. So our first split is something like B equals B4. And then we split the data, right? And so we've got 2 chunks. We've got whatever was left over, right? The, like, not our anomaly, or not our particular data point. And then we split, like, A is A20, I think was my first one. No, my first one was, yeah, it was A20. All right. And so then we split again. And then one of these was, like, not it. And then we picked, like, A equals, like, 7. And we split again, et cetera, until eventually your data point exists. And it's the only member of that subgroup. And then the amount of splits is the amount of iterations, leading to that assumption that we talked about earlier, which is that we're saying that the faster you get to it, the fewer splits you need to get to it, the more likely it is an anomaly. If you have to keep refining, think about it, that means there's more points close to it, right? And so in this case, the assumption being, and to avoid the accidental oops, we guessed it, you train lots of trees. And the splits are random. That's the beauty of it, is that if we were to pick the splits, we would add this kind of like prescriptive like element of, oh, add the average or pick the max or something that would mess with it. So really we want a whole bunch of trees all splitting randomly that give us eventually, you know, the feature that is consistently isolated the fastest is most likely an anomaly. And Strawberry Jesus, we're going to talk about distance metrics. This is just one metric that we can use. That's a great drawing. Look at that. That's going to stand for all time. We do have some tunable parameters here, and so I always like to talk about those, so that you know that what you can tune here, what you're able to control. And Melvin QQ, thank you for following. Can this be used to find a KNN graph? Hold to the KNN questions, please. You all are jumping ahead. I love you. You're so excited for anomaly detection. We will get there, I promise. And I have the coolest thing to share with you, so this might be a longer stream because I don't care if we don't have the time for it. I want to tell you about it because it's so cool. Okay. Our tunable parameters here are a number of trees. If you're using scikit-learn, which we'll be using, this is going to be called N estimators. You can also tune contamination. And this is one of the things I like a little bit less about this method, but that's okay. A little bit of a spoiler. Contamination is the expected fraction of anomalies. I don't like that. I like things where in a truly difficult, unsupervised, annoying data that's completely just messy situation, I might not know my expected fraction of anomalies. So this is just like with the k nearest neighbors, where we're like, crap, we have to pick k. We have to feed it what we think, what our incidence of anomalies is going to be. And Dark Foresty, you say, from the UK, thanks for doing this. Of course, absolutely. This is just, we're only halfway through. Isn't that wonderful? Like, on the one hand, I'm very excited. I'm proud of myself. I'm like, I'm halfway through. I did 6 of these. Almost 6. But then also I'm like, oh, I'm already halfway done. These are really fun. Okay. You can tune the sampling. Like we talked about, be careful with your sampling with anomaly detection. And you could also tune the max number of features. Because just like with our random forest, we're gonna be choosing a random subset of features to sample on, to build our trees off of. And as always, we have pros and cons. All right. Some of the pros, I would say there's linear time complexity, which isn't like perfect, but hey, it's pretty. Compared to a lot of things, that's pretty good. It does do well, performs well with high dimensions. So high dimensionality, lots of features. We're okay with that. Cons, you have to estimate the incidence of anomalies. And I would say you do lose a little bit. You lose some. A little bit. It's not as explainable as some of the other methods. Okay. What the hell? Did we already do 45 minutes? I guess we have. I keep getting surprised that I'm through 45 minutes. It's a 45-minute track of holiday music. Okay. So, pros, cons, tunable parameters. All right, I think we're ready to do some code. Let's put these things aside. Where did I just put my stylus? Put that back in its holder because I'm an adult and I put things away where they belong. All right. %150%. We're going to import, even if I'm not using, these are just my standard imports every day. We are building, this is anomaly detection. And we are building an isolation forest. Okay. And we're going to use the data from yesterday. That wonderful Spotify dataset. So I'm copying these commands from yesterday. But we're just dropping those string features because we can't use those in our model. This is the Spotify data set of all of the songs from what, like 1921 to 2020. And, oh no! YouTube is so finicky. Hold on, I'm gonna like put up a little thing. Hold on. I'm going to put up this thing, and then let me just adjust one thing here so I can see my notes. The 150% is wonderful, all of you, but it makes my notes like super big and I can't see everything. Okay. Cool. All right. Is this my Spotify data? Nope. It's a publicly available Spotify data set. And arrhythmia, you asked, what is the percent matplotlib inline? This is a magic function that you're able to do with matplotlib that allows the graphs to be displayed in your Jupyter Notebook alongside your code. It just returns it right there in the cell. So a little bit of a handy, okay, I'm moving you, YouTube, because you keep stopping. I think it might be like a space bar thing. All right, whatever. YouTube, all right. And so we are dealing with decision trees. So what is our first step? What is engraved on my tombstone already, probably? All of you wonderful humans who've been here for not shuffling. Not in this case. We don't need to shuffle our data for... Yes, scale it. Scale it. Yes. Music to my ears. All right. Yes. All right. You almost got it, Arrhythmia. It's okay. We don't need to shuffle our data for clustering. For any kind of clustering or distance metrics, I'm doing decision trees. And in this case, we're randomly sampling it, so we don't need to. Sorry. Jumped ahead to the next part. I almost gave away spoilers. Don't listen to me. She could just and rewind that. You didn't hear anything. We're not doing anything next. No, this is the end of stream. You heard nothing. All right. And from scikit-learn.ensemble, as all of you so wonderfully pointed out, we are dealing with another ensemble model, but you all are now experts in ensembling. You know that already. It doesn't scare you. You know how to do forests. It's no problem. Melvin QQ 7 minutes ago followed. I'm so sorry. I think I might have missed that. I think I was overly excited about trying to draw something. But also Bruda and Kachomsky. Kachomsky. Nice. Thank you for following. And Skolopos. Thank you, thank you, thank you. All right. So, let's build our model. Actually, for those of you who are new, I'm so sorry. I'm being a little bit rude here, aren't I? Here's what the data looks like. So, we have columns or features, right? If you think better in like the Excel spreadsheet kind of format, feel free to think about every time I say features, think columns. Every time I say data point, think rows. If that works for you, that is totally fine to think about until we get to imagery. So until we get to computer vision, you have my full permission to think about it that way. So what features, what columns do we have? Valence, which was like the upbeatness, if I remember correctly. Year, acousticness, the artist, danceability, duration, energy, all kinds of wonderful things. The key, the liveness, the loudness, the name, how popular it is, the release date, the speechiness, actually, year and release date. Oh no, I dropped release date. The speechiness and the tempo. We're gonna drop some of these that are a little bit yet less useful. Okay, but this is pretty much what our data set's gonna look like. It's also bonkers. It's pretty large. But we like more data, especially if we're dealing with unsupervised learning, but really any kind of machine learning, more data. More. Always more. Okay. So when we think about 100 years of human beings creating songs, how many of them do we think are outliers or weird? I guessed when I did this, and I guessed 10%. This is just a guess, all right? 10%, 90% are probably within a similar, like, all of Frank Zappa. Well, just you wait. We'll be able to see what our various algorithms think are weird, so. And thank you for following I See Red and M Brethren. Thank you for following. This might take a few minutes. So I'm going to set up a couple of things while we're waiting for that to chug-a-lug. And I don't want to drop audiobooks, actually, because I'm interested in everything. I really am. Define weird. Oh, now we've been through this. What's an anomaly? In this case, I mean, I think you can answer this. I just explained it to you. How does our isolation force define an anomaly? That's what we're looking for. All right. So, have I seen Halt and Catch Fire, and how many times have I been asked that? I've never seen it. Oh God, am I just like outing myself as somehow like uncultured? Ian, Alex Hart, thank you so much for the bits. Thank you, thank you. And Warrior Giggles, hi. Thank you. Yes, I'm alive and well. It's good to see you too. I haven't seen you in a while. How are you doing? And we'll give this a second. It's probably still chug-a-lugging a little bit. Some of these models might take a little bit longer. One of them I'm actually going to start fitting before I even tell you what it is, so that it can like kind of just do its thing in the background. So now I'm going to filter really quick. I'm going to filter our raw data by where our anomaly is equal to -1. That means it thinks it's an anomaly. So what are we looking at? Well, it definitely didn't like the Rachmaninoff. That's good to know. It thinks Rachmaninoff's Piano Concerto No. 3 in D minor. Ooh, I like that though. That one's good. In any case, it thinks that is an anomaly. But remember also that we have this score, right? Because we were able to quantify anomalousness. So we have a measurement, not just whether or not it's an anomaly, but how anomalous it is. So let's look at let's look at the wackiest songs, okay? And if I wasn't afraid of getting like a DMCA or something from YouTube, we might look up these songs and listen to them. But I've already gotten copyright weirdness from YouTube, so I'm not gonna risk it. All right, the weirdest songs. The weirdest songs. The sample size, I am not subsampling here. I am just, wow, it really doesn't like Sleep Baby Sleep Ocean Sounds. It thinks is the weirdest. Okay. 2050 Beach Waves and Soothing Brown Noise. It thinks is one of the weirdest. What is that going to be? Anomalousness, hold on. Yes, I want that. Okay. Had to think it through really quick, sorry. Poor Rachmaninoff. I like Rachmaninoff. Well, I have a love-hate relationship with Rachmaninoff, honestly, because I'm a human being with small hands. I got tiny hands, and I love listening to Rachmaninoff. I can play Rachmaninoff, but he hates people with small hands, because some of those chords, I'm like, look, bro, like, I got an octave, I've got a ninth, I can stretch, and on a good day for some chords I can hit a 10th, but like, seriously, just because you have monster hands doesn't mean the rest of us piano players have monster hands, so cut that shit out. And I'm tired of having to like fudge the chord because I can't reach. So it's a love-hate, you know, I'm getting over it. Deep Rain. So maybe it's like upset at some, it looks like maybe it's thinking some, or no, is that the, God, hold on. The Rain Library. It thinks a Metallica song. Hold on, which Metallica song does it think is weird? Yes. A live performance of, I don't know much Metallica, of Whiplash in Seattle 89 is apparently anomalous. It really does like not like Baby White Noise. Maybe because if there's a lot of music in a library that the white noise is gonna seem weird. I think that could make sense. All right. In any case, let's see, did I want to do anything fun with this? Or were we just looking? We're looking, because I'm saving some of the fun comparisons for later. Metallica slow jazz. Metallica for your baby. Metallica cradle lullabies. I'm sorry, just kidding. I'm just like imagining this parent like, rock by Metallica. Like, it's good. Oh my God, all right. In any case. So we've done one way of finding anomalies in our data. Whether or not we agree with it, this is one approach. Definitely seems to be highlighting,
Hold on. Wet. Oh, this is the stupid. Hold on. I hate this. I love you all. I know. Just give me a second. I hate the, like, the 150 thing. So this is right above that one. All right. Hold on. Fireside chat on government and capitalism is apparently anomalous. All right. In any case, Franklin Delano Roosevelt has made our top 20 of the weirdest fucking things on Spotify. Hemingway Poruski is consistently an anomaly. It's just like, this should not be. Like, this is just weird. I don't know if it's the fact it's Russian or what, but also I need to go up. Actually, I'm kind of curious. Hold on. You see nothing, chat. Nothing is happening. I don't even know. I'm so, like, nervous now that I'm putting this stuff on YouTube. I don't know what gets YouTube videos taken down. So I'm looking at my Spotify right now. And I just want to see. I don't think it's not bad to show you my. I can show you Spotify. So here's my Spotify. Let's search. Yes. Ernesto. Commentary from Ernest Hemingway on the film. Something Spain? Zemlya? I don't know. I'm fudging my way here a little bit. That's somebody else. That's Valentin Gaft. Maria Babanova. Anyway, in any case. Ernest Hemingway, yes. 285 monthly listeners to Ernest Hemingway in Russian. This is where I wish my dad was here. My dad speaks fluent Russian and Ukrainian, and he could help us out. Chapter, I think that's chapter, would be my guess, maybe? I don't know. I'm struggling here. All right. In any case. Oh, yay, Matt. Hi. Rebirth Pages. Hi. I'm sorry I missed this. I was going down the rabbit hole of looking up what the hell even is Ernest Hemingway in Poruski on Spotify. I've got to tell my dad this. He's going to find this hysterical. All right. Is part Chastis part? Thank you. Thank you. Thank you, MC Childs. I knew I could rely on you to always come through with translations. All right. So we've talked. Let me see. How are my notes looking? I'm trying to fill up more of the space in a symmetrical way. Oh yeah, look at this. Good job, me. So that the pictures are less just a long line, and they're more aesthetically pleasing. I'm learning slowly, friends. Like, when we get to the Math Monday streams, I'm going to be a pro. It's going to be great. You all are going to have such amazing resources, and I'll actually know what I'm doing for once. All right. So, let me catch up on chat just a smidge here. Goofy Lagrangian. What is the point of a Russophone husband otherwise? You say, and Slater USA, thank you so much for following. So how do they use unsupervised learning to come up with recommendations for songs? What is the feature space? Do they actually look at spectrograms and frequency components to detect nearest points? I have no idea actually how Spotify does it. I would say you could do recommendations for sure. Any of the anomaly detection or clustering that we talked about previously, so like k-means that we talked about yesterday. If you are finding similarity, oh no. Sorry, friends. This cold. All right. If we are measuring similarity between things, we can simply cluster a user's, we could cluster the songs that they like and make recommendations based on that. You could also kind of do it in an inverse and do any of the anomaly detection methods that we've talked about and only recommend things that are significantly less than a certain threshold of weirdness.
But you know what, Goofy Lagrangian, if you're in Discord, we can talk more about methods for recommendation engines, because that's a whole area of machine learning. Yay, thank you. I'm working really hard on making the boards better, so I'm so glad. Can I rate Rachmaninoff out of 10? To play or to listen to? Because I'll say playing Rachmaninoff sometimes feels better than actually listening to Rachmaninoff. I'd say he's about a 7 out of 10 on my list. Please evaluate his etudes tableau. No, this is not a classical music stream. It could be, maybe. I'll tell you, you know what? You want to know who's my 10 out of 10? You want to know who's my classical music bae? Is Chopin. I would marry Chopin. I don't know anything about Chopin's personal life. I am madly in love with Chopin's music, though. I love playing Chopin. I love listening to Chopin. He's wonderful. All right. So, now we're getting into some cool stuff. Are you ready? If I don't lose my voice, I refuse to lose my voice. If I limp over the finish line of this stream, like whispering into the mic, I will, because I have so many cool things to tell you. All right. So, and I cannot play you any, not right now. Loafbone and I are actually working on a duet, so maybe at some point when Loafbone and I finally start practicing again, we're working on a Schubert duet. If we can play more, and I can stop playing the video games, and I can get my butt back on the piano bench, and we get through it. We should do a recording. That'd be really fun, or like a stream play. Okay, so we're gonna talk about another method. Oh, we're getting into the good stuff. Yes. All right. I haven't built an isolation forest before, like actually, like deployed it, built it, full scope, like architecture of the machine learning wonderfulness. Every model from now on I have built and like actually used in situ in a real life machine learning context. So I'm so excited to talk to you about the cool stuff. All right. Ian Alex Hart, thank you for the bits. Okay. What am I talking about? That's right. Local outlier factor. Lof. Little Lof. All right. As if this wasn't already the cool stuff. Oh, thank you. I'm glad you find it cool. I do too. I love it all. And one of the coolest things for all of you in stream has been being able to build these models that I just haven't had an opportunity to build so far. Like they just haven't fit the situations I've needed to build models for. And so it's been cool to be like, I've always wanted to just do a stream on, or like to build something for whatever. And it's cool to have a chance to do some of that for you. Okay, now I will warn you. All right, buckle up, my friends. Because we're gonna have to deal with, this is gonna be a little bit, not more math necessarily, but we're gonna have to deal with a lot more terms. But I promise it's worth it. This is getting into some really, really cool stuff. So stay with me, please. All right, and if at any point you're like, you've gone too fast, this doesn't make sense, speak up. Because I can tell you the first time I learned this, it did take me a while. And I had to like read a bunch of papers and like read about it and slowly but surely sort of absorb it into my brain. So no, Slater USA, that is not an appropriate response in this channel. My friend, this is a pro math stream. This is a math safe space of loving math and embracing math, and math is beautiful and it's okay to be afraid of it, but it's wonderful. All right? We love math. And Math Monday streams coming soon to my Twitch stream near you. So I'm here to make math awesome. So please, no more saying ew math, all right? Math is awesome. And Kevin in Canada, thank you for following. All right. Okay, math is okay. Well, that's better. That's better than ew math. You know, I've gotten you past ew math and I've gotten you to math is okay. So you know what? I'll take it for now. All right, so this is, and Just as Good Joe is gonna love this. This is a density-based model. Now density, oh my goodness, Raiders, hello. Thank you, Alta 4. Hi, Raiders, welcome. You've come at the best part, finally. Yes, all right, I'm so used to Raiders popping in as I'm like,
And that's the stream. So I am so glad all of you are popping in at the perfect time because we're about to talk about one of the baby brother, little baby sibling of one of my favorite anomaly detection models. So, oh my goodness, there's a lot of follows. So I'm going to get through this. Hold please. Bro Toss, Showboater69, Shay Almost, The Brit Guy, Preston Codes. Thank you for following. We'll do a tiny little recap here for those of you who are new. Indifferent Ghosts with the gift subs, thank you. And now Nico CS, Damned Logician, Scott91E1, CK Darby, and Zabby Oz. You have subs! Thank you so much! And thank you for supporting the channel. I've been putting a chunk of a work into this channel, so I'm so grateful for your support. I've been prepping this stream. What is it, MC Childs? I told you I had to go prep it since 3, and I started streaming at 7. So I work hard trying to create these streams for you, so I really appreciate the support. Thank you so much for following. Nate Lift 151 and Night TARDIS and Dennis Bot, Redeemed Hydrate. Cheers, my friend. And Tracker0011, thank you for following as well. All right, so what the hell is even this stream? This stream is one of 12 streams that I'm doing in a series called the 12 Days of Machine Learning Myths. I'm going to switch really quick to the schedule so you all can see a visualization of it. This way. Yes, I guessed right. All right. Here is the 12 Days of Machine Learning Myths. You can see each stream is going to be about 7 p.m. Eastern Standard Time. So far, we've covered linear regression, logistic regression, classification, random forest models or ensembling, and unsupervised learning with k-means. If you're like, oh, damn, I missed some. I'm so sad now. Loafbone just put in chat the YouTube channel where all the VODs will be posted. The code from each night, as well as the Blackboard images that I write notes on, are available on GitHub. And detailed notes with math and diagrams and stuff when I sit down and make it look pretty and, you know, make my notes look less like chicken scratch, we will be available following the series of streams. I'm organized Stannis for King. I have had 2 weeks off work, my friend. I took 2 weeks of PTO, and I used those 2 weeks of PTO for all of you. So I've been spending the daytime prepping for each stream, and at night I stream. Just for all of you. And DeFleur, thank you for following. Let's get back to the good stuff. And oh my goodness, keep going. Thank you so much for the donation of $100. That is incredibly generous. I really appreciate it. So far, the stream has allowed me to get things like this wonderful tablet to write on so that all of you don't have to deal with my god-awful handwriting via a mouse. Now you get to deal with my god-awful handwriting via a stylus. So the donations are so helpful. I really appreciate it. It makes a lot of the hard work worthwhile, especially when I take time off work. Like, it helps. Treats for the dogs as well. Yeah, treats for my dogs and cool swag for stream. So thank you very much. I deeply appreciate it. And let's see. My schedule looks like a conference poster. Well, guess what, Captain Carrot? I've got a spoiler alert for you. I downloaded a template for Microsoft Word. I'm not a design gifted human being, so I just downloaded a random free template and put the stuff in it and tweaked some of it, and there you go. So I appreciate that it looks good because, yeah, I don't really do design. And let's see. Slater USA is a fun story. I used to live in Northern Virginia, worked in web dev, and a dumb headhunter tried to get you into BA. I don't talk about work on streams, especially streams that will be posted to YouTube later. But I would say slightly you might be missing out a little bit. I've been impressed with some things at work, and obviously we all have issues with the places we work. But it's all right. We can join Discord. We'll chat. And Opti21, wait a minute, keep going ×2. What are you? Is this a bot? Is this getting my hope up? Wait, no, because it says 300. Wait, I don't. These are huge. Wait, what are you doing, friend? Oh my goodness. Okay, I just yanked the stylus tip out of. Oh God, shit. How do I put this back in? I got too excited about the freaking donations. I panicked and pulled the stuff. Okay, is this working? Oh, thank God. All right. I got really excited and pulled the stylus tip out. Wow, oh my goodness, keep going. Okay, literally, you broke me for a second. Thank you so much. This is incredible. Goodness, I don't think I've even seen you in stream before, so hopefully you will benefit from the stream. No, I don't want my heart rate monitor on. I am wearing, hold on. I'm wearing my my smartwatch, and it just actually sent me an alert being like, "Are you stressed? You know, you should try some breathing exercises." So that should tell you where I'm at right now. Druskus and Opti21, I don't want you all to fall into the background. Thank you so much for following. And welcome all of you beautiful raiders. Today, we're talking about anomaly detection. Not just that, we're talking about anomaly detection hard mode. We are talking about anomaly detection unsupervised, which means we don't have the answers. We're flying, you know, without the answers, without a map here. It's difficult. And Captain Carrot and Dipsu and Druskus, did I miss anyone else? No. Thank you for following. So far, what you've missed, I'll catch you up a little bit. We have built what's called an isolation forest. So we built an isolation forest to look at weird songs in our Spotify dataset. Looking at you, Franklin Delano Roosevelt. And also Rachmaninoff, not Rachmaninoff, it was Ernest Hemingway being read in Russian really bothered our isolation forest as well. So now we're moving on to a new kind of model. And this model, I'm so excited. Literally my notes, I'm looking at them right now. There's all the cool stuff about this model. And then there's a part that literally in giant, I'll even show you. I'll show you. You get a peek behind the scenes. What's this? Oh, what does it say? If we have time. If we have time. I will make the time. I'm so excited to tell you about some of these models. That was your little like sneak peek at what's up and coming. All right. Isolation Forest was really cool, but do not fear Opti21 because all of the notes, these notes right here, explaining all of this wonderfulness in pretty colors will be available on GitHub, and the code will be on GitHub, and then the VOD will be on YouTube. So if you've missed out, don't worry. Everything is being recorded. So every mistake I say will be there eternally for all of posterity. Joy. So I just started talking about one of my favorite anomaly detection approaches, which is something called local outlier factor. Yinner Join, thank you so much for following. And I use Jupyter Notebook for the code for now. For our bigger models, we're gonna have to move away from Jupyter Notebook. There's kind of like a computational limit there. But for the Blackboard, I just use Microsoft Whiteboard. Whatever. And I put a black background, because, you know, I'm a gamer, yo. I like dark mode. Okay. So, the first thing, I had only said one thing, so don't worry, you haven't missed out on anything, is that this is a density-based model. All right, so when we're talking about how we define an outlier here, we're defining an outlier based on density, the density of our data points. Now this, just like our isolation forest, needed you to remember some stuff about decision trees and random forests. This is going to require you to remember a lot of your k nearest neighbors. How do people feel about their k nearest neighbors? Are we all like, we're all neighbors? We all feel good? We're like, yeah, this is an easy model. Like, we've got it under our belt, or do we need a refresh? It's cold. All right. If I keep coughing, I might actually switch to tea, because the tea's helped me get through previous streams. The last few streams, I've just been chugging tea, and it's helped. All right. How do you feel about k nearest neighbors? Do we need a refresh, or are you all like k nearest neighbors experts at this point?
hot tea is the best, Shay Almost, especially when you're, struggling through a cold. I actually, so those of you who are concerned about COVID, I know I saw somebody say COVID in chat. Two things for you, my darling. This is my COVID test. So fear not, I will be taking that probably tomorrow. And I actually have just gotten approval to get my COVID vaccine next week. So next week I get my COVID vaccine. So hopefully if I don't have COVID, I'll be safe. All right. So long division. Well, guess what? Zalbag 101. Maybe you're being sassy, maybe you're not. After the 12 days of machine learning, miss, you all seem to have really loved these prepping streams, these streams where I prepped a lot more and I've got a lot of content and notes and stuff to go through. The next series of streams following the 12 days of machine learning, miss, is going to be Math Mondays. And so we'll be starting all the way back at algebra. So if you are feeling panicked about the math, you're like, I see people loving math, I want to love math too. You are ready to face your fear of math, or you're just like, you want, challenge accepted, make me love math, I bet you can't. Trust me, challenge accepted. I've got 15 years of teaching math under my belt, and I've never once failed to get a student to at the very least, be good at it and go, all right, this is okay. I don't want to do it for the rest of my life, but all right, I see what it's about. That's the minimum here. The maximum is I want you to fall in love with it like I do. So, Shay Almost, thank you for subscribing. Oh my goodness, thank you for supporting the stream. And Alt4 F4 needs help with his math. Well, if he wants help with his math, I have no problem tutoring him. So that is his call. And don't worry if you got left behind in high school, Zalbag. You say you got left behind in high school. You're ready to deduct anything you get from your taxes. Well, this is free tutoring, my friends. All I ask is you stick around, you keep me company in chat, and we'll get through it. Though I secretly hope I'll be able to convince you how amazing math is along the way, because math is beautiful. It really is. I fell in love with it in high school thanks to a really good teacher. So I hope I can pay that forward and all of you can see the beauty in math, at the very least not be as anxious or fearful or confused by it. And you'll see the power and the beauty that it brings to all the things. See, I can meme. Toyo 2022 and Glex, thank you for following. So Captain Carrot, I've done both. So I have taught, I was a TA, so I taught labs and I did tutorials in astrophysics, physics, and math at the graduate level and undergraduate level. I've taught math classes at the elementary and middle school level. I have taught classes in history, writing, and English and philosophy at the high school level and middle school level. And I've tutored one-on-one in all subjects, K through college, as well. Okay. And he said, what is the formula for beauty? Well, aesthetics is an area of philosophy, my friend, and we could talk about that, but, I don't want to get too off track. If you all want a Philosophy Friday or something, I can make it happen. But in any case, kindness and skincare. I like that sass. Socrates might be rolling over in his grave, but that's fine. We'll take it here. All right. Little bit of a review of k-nearest neighbors. So let's say we've got some data. We love our data. Data's where the fun is, right? So let's say we got some data. All right, this is our happy little data. Can we have Philosophy Friday on Mondays? No, Mondays are for math. Get with the program. All right, k-nearest neighbors. Let's say k. We're gonna for the sake of my poor drawing ability, we're gonna say k is 2. Let's say we look at this little friend here. His nearest neighbors are these two. And by nearest, in this sense, we're talking about distance. And fear not, my friends, because if you're like, oh no, distance, what does that even mean? We're going to be using what is called the Euclidean distance. Oh God, here comes terms. Oh no, everyone's fleeing. They're running away. They're never coming back. No. So all we're talking about, God, why did I like drawing it the other way. So if we have 2 points, let's say we're trying to find the distance between these 2 points, all right? We're going to take this real quick and we're going to zoom in. All right, so we've got 2 points. And we want to know the distance. Now, I'll give you a hint. I'll get y'all started here. Don't ignore the Euclidean. That's just a stupid word. Sorry. It's fine. It's all right. He'll deal with it. It's hard to write a dashed line. All right. This is your hint. Oh, no. Yes, Femvox fan! Coming in with dropping more awesome terms. That's right. We're going to look to our dude Pythagoras here. The distance between 2 points in 2 dimensions, our x and y here, right, is just, you know, we've got a height and a width. We got a change in the x direction. We've got a change in the height direction, right? And so who remembers Pythagoras? Let's see. Jihad Joe, what a name. Thank you for following. Okay, well, Figgle, I love you, but we're gonna stick with the Euclidean distance metric. You can look up Minkowski, you can look up Manhattan. We've got lots of different distance. Yes, just as good, Joe. I'm gonna rewrite that slightly here, as our distance is the square root of our height squared plus our width squared. If you want to think about this in terms of x and y, if that's what kind of gets you, you know, helps your brain. Well, I wrote that weirdly. I don't know why I put the parentheses there. Maybe just to match. I'll write this more sensibly. I'm sorry. Okay. Square root of the sum of the squares. That's it. It's okay. This is our little review. This is our 2 nearest neighbors, and we talk about the distance from 1 point to those 2. Now, I'm so sorry. Now that you're feeling comfortable, I'm about to rock your world a little bit. Very rarely do we deal with 2 dimensions in machine learning. In fact, oh God, how many dimensions are we dealing with currently? Let's see, hold on. This thing. 22. So actually, all things considered, not bad. Our current data set has 22 dimensions. So, can I move my camera? Oh no, I will move the blackboard for you. I'm so sorry. Thank you for telling me that it was in, my face was blocking your learning. There you go. All right. So, what was I saying? Pythagoras, we got that Euclidean distance. All right. K nearest neighbors. When we're talking about K nearest neighbors, we're talking about K, a number that we specify, the nearest, our Pythagorean distance, our Euclidean distance. We're looking at the data points closest to a data point that we specify. Who's in the neighborhood? Who's nearby? That's what K nearest neighbors is about. So let's get, but unlike K nearest neighbors, where we were looking to classify and predict a label, we're doing something cooler this time. We're trying to find anomalies. And Guy John, thank you for following. All right. So just like with all of our other models previously, we have some assumptions. Ew, why is that thick? No, makes my handwriting look bad. All right, worse, I guess. Assumptions. So the key assumption for this model is that the density, that's not an I, the density of points, data points, let's be specific. The density of data points around an outlier will be different than around a normal data point. It's going to be something like getting the sum distance from K near. So you are so close, Strawberry Jesus. You're like headed in the right direction. So stay with me. It gets even cooler. All right, seriously, I was walking around the house like geeking today when I was prepping this. I was like, yes, local outlier factor. I'm so excited. I'm a nerd. In any case, we're going to need a couple of definitions here. So stay with me. This is going to feel a little academic, but we will build this model. So do not flee. Do not be like, oh God, this makes no sense. If it does make no sense, say something and I will explain it better. Call me on my shit. Ian Alex Hart, thank you so much for the bits. Glex, no, clusters. We did clusters yesterday. So yes, yesterday. So if you had bad experience with the clusters, please check out the VOD from yesterday. I think I did an all right job. You can ask chat. We talked about clusters, and clusters weren't so scary, I promise. Okay. Our first definition that we need to understand is something that we're going to call the K distance. Ooh, that lag. Brian Bernales, thank you for following. All right, so what is the K distance? The K distance is going to be the distance between a point and its kth neighbor, aka its furthest neighbor. And let's see, Barrelicious, thank you for following. And Strawberry Juicy asked me, how do I manage to write? Is that a straight line? Well, not all of my writing is in a straight line, I assure you. What do you think, Loafbone? Do you think Hubble is ready for treats, or do you think we should do a little bit more math first? Can you kind of do a check on how sleepy he is, and if we're ready for some treats? Because we can do a tiny doggy break. I'd rather do it before we get too much into the details of this, because I don't want folks to get distracted. Quick treat break. You got it, my friends. Hold, please, while I set up the treat camera. Ian Alex Hart has been waiting so patiently. So let's give the dog some treats. Ian Alex Hart here has like been banking up like 50 treats. So all right, it's thinking about it. It's connecting. Sorry, give me 1 sec here, and then we'll meet the dogs. You'll meet one of the dogs at the end of stream. Tennessee, he will sing to you. Who? Oh, we got both of them. Look at these boys. All right, let's start cranking. See the Kong on the floor? That was to try to distract Hubble while I was rebandaging his leg. Oh, do they hear the noise? Are they coming over? Tennessee's looking at it. Oh, here's Hubble. This is Hubble. And this is Tennessee. And let's just start cranking out these treats for them, because they're very good boys. And Ian Alex Hart is like, hello, I've been putting bits in chat since the start 2 hours ago. Give these dogs some treats. They're very good dogs. Hubble is indeed named after the Hubble Space Telescope, like a very good boy. Because I don't know if you can see the quality's a little bit low, but you can see he's got spots on his nose and spots on his paws, so he's a constellation boy. Very, very good boy. Also, Main Village, if you're still in chat, those are your Christmas presents. Because I suck at mailing things. Hubble. Oh. No, don't walk away, you goofy boys. Hold on. Let me pull up the Furbo on my phone, and I'll get them to come back over. Because the app on my phone. All right. They're walking away for some reason. What's better than treats? Hubble. Hubble. Hubble Bear. Do you want a treat? Tennessee. I see you want treats. But boys. No, he's running to my office. Crap, I'm trying to get my voice down. Boys. Boys. You want treats? Hubble. Tennessee. Boys. Boys. If I do weird sing-songy stuff, sometimes they finish. Hubble. Oh, he is look at, you can see his little leg there. He's just ignoring me. Hubble, why are you ignoring me? Hubble.
Hubble, come. Hubble. Oh shit, he's looking down the hallway. Hubble. Hubble. Go to the furbo. You don't know what that means. Oh, good boy. Yes. Hubble. Hubble, hubble, hubble. You want treats? Oh god, this is the story of having a dog. I'm like, love me. Please, love me. Don't hate me. All right, he's ignoring me. Whatever. He's a good dog. Oh, there he is. Good boys. Oh, they think they're going outside. No, maybe. I used the outside voice, so maybe they think they're going outside. In any case, thank you, Ian Alex Hart, for the slight break of the doggos going outside. Like very good boys. Or getting them treats, at least. Now they'll probably go outside. Anakin Luke, we are taking a small break from learning about local outlier factor to give my dogs some treats. All right. So, are they hitting my door? Might be. Okay. So, distance between a point and its kth neighbor. What does that mean? All right. Yet again, let's set up our little data landscape here. Let's give ourselves some data points. Let's say that this is the point that we're considering. And we're going to have k equals 5 here. So the k distance in this case, first of all, our 5 neighbors here are going to be these 5. And the k distance, oof, it's chalky, hold on. Excuse me. The k distance for our point is going to be the distance between this and the 5th neighbor. Sorted, of course, by distance. And Arrow Wraith, thank you for following. Arrow Wraith. Let's get that music back. Nope, that's not it. There we go. We need our holiday music. This is Machine Learning Miss. We are celebrating how cool machine learning is. All right. That's just the k distance. Does that make sense? Does everyone feel good with that? It's just depending on what k we specify, if we were to sort the neighbors by distance, it would be the distance to the furthest neighbor. Oh, yay! I'm so glad you said you were fine. Arrow Wraith, you say you're trying to find a good science channel, and here I am. I do my best. So you have stumbled upon the 12 Days of Machine Learning Miss. So welcome. I'm so glad you're here. Following Machine Learning Miss, you can get science content here with Science Sundays and Math Mondays. Tuesdays are viewers' choice, so you all get to pick what we do. A lot of times it's video games. And Thursdays are me learning game dev from Strophium in chat. So lots of adventures, lots of fun. Okay, so I'm moving on from k distance. So everyone feel good with this? Speak now or forever hold your snoot. Okie doke. So next. Oh, by the way, yes, Strophium. Reachability. On Math Mondays seem really good. I'll tune in regularly. I'm so glad. Okay, good. Well, welcome. Reachability distance. How long do you have to hold your snoot? Well, if your snoot is concerned with k distance, you should speak now. Otherwise, you have to hold your snoot for a while. All right. Reachability distance. Okay. So now we're going to be talking about, instead of just considering, a particular point and its k neighborhood, if you will, we're going to be considering 2 points. Let's say A and B, okay? Oh god, I got to draw them again, don't I? I'm trying, chat. This is a very visual stream, and I'm doing my best here to give you some drawings that aren't horrific. All right. So, no, if you need review, ask your questions. Have no fear. That's what I'm here for. Let's say this is A. In our first example, this is going to be A, and this is going to be B. And we're going to use our same example from earlier of k equals 5. So from A, let's look. Let's get a couple things. 3, 4, and 5.
No, that doesn't make sense. I'm trying to make it really obvious which one's the longest one. So I'll actually make this one further. It helps if it's really obvious. I promise there's a method to my madness here. All right. So if we are considering the k distance of A, we're thinking about the distance to, we'll call this C. That's the distance. And when I say distance, you all now know what I mean. We're talking Pythagorean distance, our Euclidean distance, the distance between A and C. Okay? So we've got our k distance. Reachability distance now. So this is considering the distance between 2 points A and B. Okay? If A, actually, so let me reverse this. If B is one of A's k nearest neighbors, then our reachability distance is going to be the k distance of, well, in of, we can just use parentheses, right? If B is not one of A's k nearest neighbors, then our reachability distance is going to be the distance between A and B. All right. And FemVox fan, yes, what is the significance of point C here? Point C is the farthest neighbor from A. So when we're defining our k distance as given some k, in this case 5, given the 5 points closest to A, the k distance is whatever point of those 5 is furthest from A, the distance to that point. So C, you know, we've got all of these neighbors here, the 5 nearest neighbors of A, and C is just the nearest neighbor of A that is the farthest. Farthest. I know my distances. All right. Only one Matt. Thank you so much for the gift subs to Gura Itoro, Anakin Luke, Andy Techie, Figgle, and Cherokee 442. And yes, I can move. I won't move the camera, but I will move the this a little bit for you. I feel like this is zoomed in really far. No? I'm just writing big, maybe. All right, so what does this actually do practically speaking? Because I know if you're anything like me, the first time I read this, I was like, what? Who cares? Why do we even give any craps about the reachability distance? What does this actually mean? What is this actually doing? Okay, so what this is doing is this is giving us a measurement of how A is looking at B. How far A thinks B is. Is it part of the neighborhood or no? It's kind of a measurement of that because essentially what it's doing, can you still see this? Yes, all right. Is it's making all points in a neighborhood equidistant, equally distant. So I'm gonna try to, oh God, now I gotta mimic this. I'm not an artist. Shit. This is not the same. Whatever. We will deal with it. We will deal with the bad drawings. It is part of life. All right. So essentially, this is the situation we have, right? So what this is doing is it's taking whatever the distance is, and it's saying, ouch. Who to do? We are on, I'm not an artist, so bear with me. Whatever, close enough. It's defining a neighborhood for us. It's saying all of this is the neighborhood of A. And so is B within this range of the neighborhood, or is it farther? Exactly. So Malasteph, you rewrote it in a more simplistic way. That's great. I really wanted to spell it out for people, but you can think of it, yes, whichever is greater. The distance, the k distance of A, or the distance between A and B, which is essentially asking, is B one of A's nearest neighbors? Is it in the neighborhood? That's what our reachability distance is saying. Is this part of our neighborhood? This is trying to be a circle. It's a circle that's having a bad day. It's okay. You know what? That's fine. All right. And so this is, you can also think about it like this. So let's, instead of just thinking about point A, let's draw like a slightly different picture. And I think this will help you see some of the significance here. So let's consider that instead of just worried about, point A, this whole thing's about anomaly detection, right? You may be like, Jess, when are the anomalies coming into it? Let's say this is our situation. And so in this case, we have, let's say this is point A, and this is point B. It will always be a circle or a sphere. So it's like when you take a vector that is the same length and you rotate it around all of the axes of however many dimensions we have, that's what we're dealing with. All right. So if we look at A, and we're going to keep k equals 5 still, what do A's k nearest neighbors look like? Well, here's 1, 2, 3, 4, and 5, right? So if we look at the circle around A, something like that, roughly. Okay, if instead we look at the, I want a different, we'll do dark blue. K nearest neighbors of B. Oof, no. 1, 2, 3, 4, 5. Now, the circle around B is huge. Now, A is a k nearest neighbor of B. Is B a k nearest neighbor of A? No. Their circles, their reachability distances, right, between the two are not the same. That's the key here, okay? The reachability distance of B to A is the k distance of B. Because A is part of B's neighborhood. But is B part of A's neighborhood? No. And so that's what helps us out here, is that we're able to compare the size of the neighborhoods. This is getting to that density, that Just As Good Joe was talking about. This is looking at how close are the nearest points, and are they similar? Or do we have really different neighborhoods? And if they have really different neighborhoods, their densities are different, maybe something's up a little bit. So that's what our anomaly detection is going to be looking at. And Friedrich Misantropo, thank you for following. Okay, so we're almost there, friends. Almost there. We've got 2 more steps. Stay with me. I told you we'd have a lot of definitions here. So from our reachability distance, we can get to what we call our local reachability density. LRD for abbreviation, because I don't want to keep saying that. And in this is easy, okay? This is 1 over the average RD of a given point's nearest neighbors. So now what we're talking about is we're not just looking at A, but we're saying, okay, what is the average reachability distance of each of these k nearest neighbors and A? Is A part of their neighborhood or not? So this is where we get that distinction, right? And as our reachability distance is smaller, as the average reachability distance of a particular point's nearest neighbors is smaller, our density is greater. And so we have this inverse, okay? Because it's 1 over, because as our distances get smaller, our density gets bigger. Remember, we've got mass over volume. This is our proxy here for volume. And thank you, NickRoy23, for following. Okay. And then we're so close. We're so close. We got our density. Now we know how we define density. The last thing, finally,
And k distance is a range of 0 to distance to the kth neighbor. K distance is either distance to the farthest neighbor or distance to the point in question, whichever one is largest. Our local outlier factor, I'm writing so fast, LOF in this case, is the average local reachability density of the k nearest neighbors of a given point. Oh my God, all right. And so what does this even mean? I'm going to translate this like I do for you, so don't panic if you're like, oh God, there's all these acronyms and things. Essentially what this is saying is it's a ratio that is showing you the density around a point compared to that to the density around its neighbors. Okay, so if you think about this, if we go back to our ugly graphs here, and we want to say B, is that by my head? Let's move that. B is an anomaly. So that means that the ratio, if we compare the closeness of points around B to the closeness of points around A, they are not going to be the same. B is going to have a much farther distance, a lower density, compared to A, which is going to have short distances, a higher density. And so by comparing these two, we get our local outlier factor, and something tells us B is a little bit wacky. So if we're to look at what numbers this spits out, a LOF of about 1 means that they're the same. So that's normal. Okay? So that means the point's density is very similar to that of its neighbors. And yes, FemVox fan, you're pointing out one of the challenges of this methodology, which is what K do we use? And I will tell you what the paper says, which is that K should be larger than about 15, given studies of various data sets, and less than the number of data points that you have. Wow, that's helpful. When we have 200,000 data points, it should be somewhere in the range of 15 to 200,000. So that's one of the challenges of this, is that we have a tunable metric, just like with our isolation forests, where there we had to specify what we're estimating like the contamination to be. Here we have to both specify contamination and what we think the number, the K nearest neighbors that we look, what we think the the membership in a cluster would look like. So maybe this is a case where we would want to run our k-means from yesterday, our elbow method first, pick a decent number of clusters, and then go from there. If I were to do this rigorously, I might start there. You need a density again. The local reachability density. There you go. Okay. I don't know about you, but I often learn best from just building it. So let's build away. Let's build the things. This is a decently computationally efficient method. It is. Ish. I'll get it. No getting ahead of me. Cool things up ahead. Cooler things. Oh my god, I love this stuff so much. All right, so let's switch over to our data. All right. And let's build it. Oh, poop on an absolute bucket. Shit. Remember how I told you earlier, friends? Remember how I told you, I was like, yeah, there's this method that takes a while to, fit, so I should start it before I start explaining it to you? Moo97, thank you for following. Well, oops. give me a sec. I'm going to breeze through this. I'm picking the same contamination that we did for the previous one so we can compare the results. All right, so in practice, this took about 10 minutes to fit, and that was without me streaming. So instead, we're going to take a quick moment to explain ADHD, Strophium. Ugh. Instead, while we're waiting for this to fit, what questions do you have? We'll leave this for a moment, and we'll chat while this is fitting. My apologies, I literally made a note to myself. Unfortunately, I made the note at the end of the notes instead of where I should have paused and gone, start the stupid code, Jess. So, bye, Ian Alex Hart. Thank you so much for stopping by. Really appreciate it, as always. Thank you for your support, your subs, your bits. The dogs definitely appreciate the treats. There are options for Jupyter. I mean, not just for Jupyter, but for the scikit-learn model, you can set the number of workers that you want or to use more threads, but I'm streaming, so I'm not going to do that, or the stream would shit itself. MX00S, thank you for following. And do I do this every day for work? Do I do anomaly detection every day for work? No. I've done anomaly detection for work. Do I build machine learning models for work? Yes. Not always the same type. Sometimes it's supervised, sometimes it's unsupervised, sometimes it's imagery, sometimes it's text data, sometimes it's, all different kinds of data. So lots of different kinds of models. Let's see, actually. I guess, so would people be all right if, while we're letting the local outlier factor model fit, let's see, I read it was hard to get into data science without a PhD. No, it's not hard at all to get into data science without a PhD. I don't know who told you that. If you're looking to publish in academia or teach at a university level, then absolutely you're going to need a PhD. But no, it's not hard at all to get into data science. Most people I would say that I work with in data science don't have PhDs. And Max1, you ask, in data science, do you mainly use Python? It depends. So I've supervised a project where someone else used C#, and I've used Julia as well. But predominantly, I would say Python is usually the language of choice. Some people also use R. I would say Python is more prevalent than R. But yes. Thoughts on Julia? I liked it. I liked it a lot. Unfortunately, right now, it's just like it's not prevalent enough, and it doesn't have enough of the libraries and everything to just be as adoptable as Python, but I thought it was really, really cool. I have seen, usually, Strawberry Jesus, I get brought on to update the code from C++ to Python because people are tired of working in C++. So I've seen some stuff built in C++. Python's a lot easier when it comes to machine learning. It is. It's got a lot of the libraries, a lot of the support, and at least for, I would say, more junior roles, it's a lot easier to find developers to work in Python. I haven't seen any machine learning in C, at least not yet. I mean, the back end of I've seen Python and Python wrappers for C, because the back end of TensorFlow is either C or C++. So if you're looking into building a machine learning library, I would say, yes, you want that speed. But if you're looking into building models and learning more about machine learning, Python is a lot easier and a little bit more approachable to start with. And yes, that is just what I said. So let's see here. While this is chugging along, I think I might talk to you about what I was going to plan for the end of stream, which is something that I've built before that's really, really cool.
And so you can't make publications if you don't have a PhD. Who said that? I don't have a PhD and I'm published repeatedly. So I don't know who says that, but they are deeply mistaken. I would say a PhD often is about, learning about the process of research, making connections, and also the process of having that thesis, which is very, very useful. But that does not mean, like, I have publications and I have patents pending and I don't have a PhD. So, and Deiticus, you say, what would be good projects experience to showcase for data science interviews? So I would say that the biggest challenges right now in data science have to do with a lot of unsupervised learning or unstructured data, showing that you can do things. If you are moving, it depends. Are you moving more towards, like, even in data science, there's a slight, it's gentle and it's not specified, but there is a slight kind of front end, back end split. So if you're more interested in visualizations, I'd say you need to be able to build interactive dashboards, work a lot with like different dashboarding libraries, have effective data visualizations, have more of that front end experience. For back end, I would say being able to show that you can build lots of different models, show that you can work with different data types and also data like input types. So not just a database, but also streaming data, different volumes of data, different, supervised, unsupervised, different architectures. That's all very useful. And Acromonic, you ask, is it possible to get into data science just by self-studying? My friend, I have just self-studied. So yes, I am living proof of that. And let's see, do I use Anaconda? I use Pip. I've had enough bad experiences with Conda. Like, people have told me, oh, well, Conda's better now. They've patched it. Like, it's better. And I'm just like, it's like that person that, like, you keep going out with and they keep, like, blowing you off. Like, a certain number of times, and I'm just like, you've used up my trust. So, yes. So, Max, you ask, I guess you studied physics and self-taught yourself the machine learning stuff. I studied physics and pretty advanced math. And I taught myself programming, computer science, a bit of software development, machine learning. The statistics I hadn't taken, so I had to do that in the machine learning. The boy who cried Conda. Oh no, Justice Good Joe! Oh, you see, mix Pip and Conda. I know they play nice now. I've had that literally break things beyond repair for me, where I had to wipe everything and just start over. Albeit that was like a chunk of years back when apparently Conda was worse. I don't touch Conda. I wouldn't touch Conda with a 10-foot pole. No. I refuse. And I don't care. It's slightly irrational because I've heard good things about more modern Conda, but at this point, no. Oh God, virtual environments are your friend. Yes, please. Please don't do projects without virtual environments. That's your safety blanket. Oh. Do I use Pip in Jupyter? So you can do Pip environments with Jupyter via ipykernels. Pip environments are where it's at though. Pip is my bae. I like Pip. Pip's never done me wrong. Pip's never betrayed me. So like Conda has. Conda's a lot more usable though. So especially if people are in a Unix operating system or even I guess on Windows. I don't know. That's usually where I direct people to start because it's a lot quicker to get started. But I don't touch it anymore as a personal role. But Pip and Brew have been able to handle most things for me. Is there room? So Strawberry Jesus, you asked, is there room for ML engineers in cross-field companies? Of, for example, neuroscience, DNA, biotech, whatever, science plus ML. Yes. So, absolutely. In fact, like even recently, the places that I've done interviews or I've applied at have been biotech companies, agricultural companies. I don't know about DNA or neuroscience. I haven't done too much with that. Pretty much any large-scale scientific field will have use for machine learning. And you can use Conda if you want, by all means. I'm just saying it's like a personal preference. I've tried so hard to emphasize it's subjective. I've had bad experiences with Conda myself, but if Conda works for you, roll with it. You get burned enough times, you're like, I'm not touching that. It's like trying to install GDAL. It's just a freaking nightmare. Do I have an IDE preference? Depends on the project. I can say that now. So Strophium has shown me the beauty of Visual Studio with Unity and how they play so beautifully together. Depends on what I'm doing. Like, I've done enough stuff with like, servers and whatnot that Vim has just gotten comfortable for me. But VS Code is my happy place. Like, I've used Atom, I've used Sublime Text, I've used PyCharm, I think. That was a long time ago. VS Code is perfect. It works. Again, Soapbox Rocket and Glockwork TV, thank you for following. But it just, these are subjective tool preferences for the most part. If you have something that works for you, you feel comfortable in, you can get your shit done in, go for it. But let's see. Strawberry Jesus, you say, are there any vague borders between machine learning and data science even? What do you mean? So, I would say that not every data scientist is a machine learning engineer, and similarly, not every machine learning engineer is a data scientist. So there is a distinction there. A lot of times people transition from data science into more of a machine learning concentration. But I've met people who can build the machine learning models, but they almost come from more of like a computer science or software background, and they're lacking a lot of like the visualization, the EDA, the data prep, the statistical analysis. It's such a like nebulously defined field that I think it's tough. Hydrate, but then I have to pee. Cheers, Loafbone. And have I used any Spark Hadoop? Yep. So I've used PySpark a bit. I used Hadoop a while ago. It's been a while, so please don't ask me anything about it. I would say CS people, I've seen both, Strawberry Jesus. So Strawberry Jesus asks, so CS people tend to go into machine learning rather than data science. I've seen both. It really depends on the interests. And sometimes data science like includes machine learning. But I've met, yeah, okay, FemVox fan says it perfectly. Data science and machine learning are probably nearest neighbors. That's a great way to look at it. Actually, speaking of nearest neighbors, so while this model is training, I will get to the point of my like if we have time section, because I really wanted to talk to you about this. So since we're waiting on this model anyway, I might as well talk to you about the cool stuff I wanted to talk to you about anyway. And then when I'm done talking to you about this, we can go back and look at the local outlier factor stuff. Okay, so are you ready for this? This is so cool. So Baby Jess was geeking out because when I first studied things like k-nearest neighbors, and Hydra60, thank you for following. When I first was studying things like k-nearest neighbors, I was like, oh my gosh, distance, like, well, not even, okay, so that's something we do in cosmology, is like the different metrics for measuring distance. But for some reason, it just like, it blew my mind still that distance wasn't an absolute. Like there were different ways to approach the distance between objects. It's really cool, right? Like something we might take for granted. And Dino Sorcall, thank you for following. Okay, so, oh no, where did I put my stylus? Oh, there it is. I need to remember to put it back in its holder. Put things back where they belong, Jess. All right. So, now that you're all comfortable, you're like, you've mastered, theoretically, we're waiting on it to fit, but theoretically you've mastered, k-nearest neighbors, local outlier factor. You are feeling so good about this distance density space. Am I right? Just nod. Dauberson, thank you for following. Well, guess what? There are two problems with local outlier factor. The first is that when we're using it to classify anomalies, it can be computationally and memory expensive because we have to hold in memory all of these data points. And every time we might get a new data point and we want to ask a question, is this an anomaly? We have to calculate all of those local outlier factors. We have to figure out the neighborhoods, all this stuff. And so that means it doesn't handle streaming data very well. And we have to hold all of our data in memory. That's really crappy. That's not ideal. So, oh boy, prepare your snoots, my friends, because I'm going to talk to you about a paper I read. And I can't talk about how I read this or where I read this or why I read this or what I did with it, but I can tell you I read it. Incremental, composite, local, outlier, factor. Hi, Clough. All right. It's not a secret document. It just, the lawyers haven't gone through it yet. It's on my resume. So, like, I don't know how much of it, I can't talk about what I did for it. I'll say there's a patent pending, so I can't talk about it. In any case, Max, thank you for following. All right, so this is going to address those computational restrictions of the local outlier factor method, and it's going to address the issue of how do we deal with streaming data. So this is where instead of like just here's your static data set, do the thing, that we might have some data to start out with, but we're going to be getting our data like one at a time. We're going to be getting it as a stream. So just kind of imagine like new data coming in like on a conveyor belt, okay? All right. And Glockwork TV, so you've got a rather long question for you. Let's hope this works out. Okay. Data set's pretty hard to... Okay, so Glockwork TV asks a question about, well, I don't even know, what's the question? So Glockwork TV is explaining a scenario saying that it's pretty hard to do data science with data you're not supposed to use for other things. For example, you wrote a tool that was used to do statistics for Escape from Tarkov, and the creators blamed you for wrong data, tried to sue you for stealing data because you scraped it unofficially, and they didn't have any API. So I would say there's a reason that there's something called ethics, and if people don't have data available and they're not making their data available, like sometimes you have to deal with that and it sucks. Like, I'm sorry, but like if people aren't giving you permission to use their data, like you have to respect that. I know that sucks. I know it does. I will say that there's a huge demand for applications of data science in esports and in data science, or in video games in general. But if that data is not available and if you're scraping it, making tools, especially if you're charging money for those tools or if you're drawing conclusions from that data, I'm on PTO! I don't have a timesheet, suck it. Then it's not even about scraping websites. It's just like, if you're going to do that, if somebody gets upset at you, you kind of have to just be ready for it. That said, if they're blaming you for wrong data, it sounds like, you know, you tried to scrape things together from tools or from what you could find, but maybe it wasn't the full picture. And so it is tough. Video games make it more difficult, I would say, because it's not like a website that's sort of like publicly available. A lot of times you're having to kind of work. You're gonna have to fiddle with things a little bit. I would say I wouldn't call it gray hat science, because like one of my big areas of focus is ethics and data science. And so like consent for permissions, informed consent for use of data, like these are things that matter a lot to me. So I'd rather if we had very well-established and enforced boundaries around these things. We don't. But that doesn't make it like that we should just go out and do whatever. I mean, in the case of like Escape for Tarkov, like I don't know enough about the game. I think it was a Strophium. One of my other friends was talking about it. But I think that isn't as clear to me as like a ethical, unethical situation. Certainly for use of data in other scenarios, you have to be very careful. I'll just say that much. In any case, incremental, composite, local outlier factor. Local outlier factor, you all know, we just talked about it. And Glockwork, of course, no problem. I have no problem talking more about this, especially once we finish kind of the teaching part of the stream. It is difficult, I will say. And I agree with you. I think the next big market for data science and machine learning will be esports. I think they're a little bit behind. Some games and some teams are getting behind it, but not enough. Just saying, if any, esports teams want to hire me, I have built models to look at video games, so please, that would be very cool. That would be awesome. But in any case. All right. Incremental, composite, local outlier factor. So first, let's talk about this incremental. So this is what helps us handle streaming data without needing to recalculate everything every time. So what does that do? Well, let's draw a picture because I'm just a masochist today. All right. Let's say this is our data. We've got, local outlier factors for each of our data. And let's say we have a new data point that comes in. This one. So if we were to handle things normally, we would have to store all of these data points in memory and recalculate everything. Instead, what we're going to do, let's see, any Denmark-based esports, exactly, MC Childs, exactly. Or Sweden, or the Netherlands, or Finland. Okay. Is that we are going to hold the local outlier factor for each of these points in memory instead, but not the points themselves. And when we have a new point come in, all we have to do is look at whatever our K value is. Remember, we've been using 5. So in this case, that's not the line we want to draw. 1, 2, 3, 4. 4 and 5. Okay? We only look at each member of the neighborhood, and we recalculate the loft, the local outlier factor, for only the members of that neighborhood and the new point. So that's just 6. So instead of having to recalculate everything each time and refresh our data set, we've pruned it down. We're going to say incrementally, we just only look at the nearest neighbors. That's all. And this allows us to not just, reduce our storage complexity, but we can also reduce the fitting time because we're not having to recalculate everything each time we get a new data point. Hold on. What am I talking about? Go again. Rewind, my friend. Or does stream let you rewind? I actually don't know. What is specifically, if you have a specific question, I can help you out. All right. How do I know that K is 5 and not 10? We'll get into that. For now, for my drawing ability, I'm just using K equals 5. But we will talk about that. So do not fear. The 5 is prescriptive so that my poor drawing isn't horrific. Okay, so this is what the incremental means. As we add, we also actually, if we have certain data points that we want to remove, we can also do that with our incremental approach. I won't cover that too much right now because I'm going to focus on the anomaly side, but that can be a way to prune our data set repeatedly. And Noodle2K, thank you for following. And no, Mirander0, that's the beauty of the local outlier factor, is that we have a lot of that data is kind of already kind of subsumed in the local outlier factor. Or even then we might not need, if this is a 70 dimension data point, We might not need that. We might not need each feature's value for this particular data point, but maybe we just need the distances to the nearest neighbors. And that's it. The VOD gets uploaded in real time, so if you go to videos, you can see what's been uploaded so far. Oh, cool. All right. So, the cool part, though, I think, in my personal opinion, is the composite. This is where stuff gets really cool. The incremental is cool. It's cool enough, but the composite is what blows my mind. So get ready. This is super cool. Top secret. Thank you for following. All right. So, do you remember how when we talked about k-nearest neighbors and local outlier factor, like today, I keep talking about the neighborhood, right? So when we talk about the 5 nearest neighbors, the 10 nearest neighbors, it defines a proximity around our data point. And that is what we're evaluating, whether we're looking at our density, whether we're looking for similarity in labels if we're doing our supervised classification, whatever it is that we're looking at. We've defined our neighborhood. We think we understand what neighborhood means, right? Well, just like with distance, we are going to redefine our neighborhood because there's a problem, which is that sometimes within a cluster, within a neighborhood, there might be smaller sub-patterns or sub-clusters within larger clusters that are anomalous. And it's going to be really confusing because our current approach is going to look at that and be like, it's dense, it's fine. That's not good enough. So maybe, if we were looking at, oh God, I hate having to draw these all out because it's going to be, I will do my best. But we're talking about more complex relationships in the data now. So maybe we have something like this. And obviously, these look like anomalies. That's the first thing my eye jumps to, are these. And FX stream, we say, what are the dots? These are data points. But this right here, this cluster, might be an anomaly as well. It's overly dense. So it's not just about, the points that are sparse, far away from other points of density, but we need to be able to compare more complicated relationships between data. And data points, what's that? So this could be, I don't know. Let's think. This could be temperature and humidity. I don't know. I'm making up features. So if we're comparing measurements, that's all we're looking at. Is we're looking at different kinds of measurements of, like, the data that we're using tonight that we've used previously in stream is Spotify data. So we're looking at things like the song length or the scale that the song is written in, things like that. The year that the song came out. And just as good, Joe, you're right, multiple types of anomalies. Well, if we have multiple types of anomalies, our local outlier factor is too simplistic. Just our k nearest neighbors is not enough to find these kinds of complex anomalies. So we are going to introduce something called a composite nearest neighborhood, which is really, really cool. All right, so this is best described. I've seen it described with like set notation and everything, and it's a freaking nightmare. So I'm going to draw a picture because that's, honestly, this is what worked best for me in understanding it. So I'm hoping it will also work for you. So let's just draw some data. We're going to put some different kinds of, clusters and relationships in here. All right. And let me actually think about how I'm going to do this. So that should work. Okay. I had a really pretty picture before stream, and then I was like, wait, why did I spend all this time on this? Because I'm just going to have to redraw it. So this one, this little data point here is going to be what we're considering tonight. This is going to be our X, all right? And we are going to, two-dimensional object, yeah, it could be 10-dimensional. I think ours is 22 dimensions. And that's why it's taken its sweet time fitting. But that's okay, that's why I'm
teaching you cool, amazing other stuff. Where did I put it? There it is. So I can keep an eye on it fitting. All right. So for the sake of my drawing, K is going to be 2 for this because we're going to get into a lot more complicated relationships. And so I'm going to save myself a headache and we're going to say we're going to use our 2 nearest neighbors, okay? So our nearest neighbors from X are these 2. I'm actually not going to draw the lines because it's going to get too complicated. So I'll just highlight them or like recolorize them. So these are our nearest neighbors. Okay. So the next thing that we need to consider is, okay, remembering in my head what comes next. Let's get a new color. Let's do green. All right, are what we're gonna call reversed or reverse nearest neighbors. And reverse nearest neighbors are gonna be any point that has this light blue one as a nearest neighbor. So this one. I'm actually gonna give us another data point really quick so that this works. So these are the reverse nearest neighbors. You'll see this if you look up, machine learning, local outlier factor papers. You might see this abbreviated RNN, little r. If it's big R, it's something else, little r. Whereas, nearest neighbors here, you'll see this being K nearest neighbors. Thank you for following Kimius22. And then the last thing that we want to do is we want to find another thing. Come on, little bean. Come on. You can do it. What's another color that's obvious? We've used light blue, we've used green. I guess I could use purple. All right, we already have purple. We'll leave that green. Which is shared nearest neighbors. And you'll see this little s, nearest neighbors. And just as good, Joe, you say, could NN be equal to RNN? Yes, strawberry G's, well, no. So reverse nearest neighbors, usually just to simplify things, you're gonna take like the difference. So like the set difference between the two. So you want the reverse nearest neighbors. Yes, technically they might have the nearest neighbors in them as well. When I've built this, just to simplify it, I've taken them out because I had very, very big data, but it won't matter, and I'll show you why. It doesn't matter if they're the same. You can take them out if you worry about your data complexity and you need to simplify it. And just as good, Joe, what is the definition of reverse nearest neighbors? Reverse nearest neighbors are points for whom blue are X points for whom that point is a nearest neighbor. So blue is one of their nearest neighbors. Red are the 2 nearest neighbors of blue. Green are points for whom blue is a nearest neighbor. I know, it's tough, and drawing it out and drawing multiple drawings is the only thing that really helped me kind of wrap my head around it spatially. Shared nearest neighbors are for each of the nearest neighbors of our data point. What other neighborhoods are they in? So for this point's 2 nearest neighbors are this one and this one. So this is a shared nearest neighbor. It shares a nearest neighbor. Why are you being weird? Why is the tablet suddenly taking away the... Similarly, let's see. This would be one, and this would be one. So do they have a nearest neighbor in common? And this is related to the incremental method. So the incremental local outlier factor method came first, I believe. And then it was combined with, oh God, it's still like putting the yellow in front. I don't know why it's doing that. And then the composite method came along and they combined them, which is really, really cool. All right. So if we were to summarize this into questions though, pause the graph just for a second. So reverse nearest neighbors are which points have X as a nearest neighbor. Shared nearest neighbors asks which points share a nearest neighbor with X. If that helps you think about it, think about those questions. So now we have something that's called the composite neighborhood, which is, maybe I shouldn't make it so thick. I'm gonna use a highlighter for the first time. What's the color? Maybe gray, as boring as that is. Come on, little bean. All right. And so the reason why we're expanding this definition of our neighborhood, and I know this is a stretch, so don't worry too much about this. We're not going to build this model. This is just like a really cool paper. The reason why I wanted to show you this is we've talked about ways to expand our distance metrics to make them fit our situation better. This is a way that we can expand our definition of neighborhood to also kind of fit more complicated situations. So instead of just, our normal nearest neighbors would just be right here. This would be all we're looking at. That's it. But when we expand to include our reverse nearest neighbors and our shared nearest neighbors, we get a bit of a bigger picture of the relationships and the data that's around X, our blue point here, X. And that can help us when we're identifying anomalies because we're not limiting ourselves by, just looking at the points closest to it. We're also thinking about points that might have more complicated relationships, both with X and with X's closest neighborhood. Are there any libraries which implemented this? Not to my knowledge. I had to build it from scratch. Can you see the definition of which one, Onad? And why do we expand to those two, King Von Edward? Because we are worried that if we only look at local outlier factor, if we only look at our nearest neighbors, we're taking a very narrow view of the space that our data occupies. And if there are more complicated anomalies, if there are anomalies within sub-patterns within patterns kind of situation, we're going to miss them out if we just look at the nearest ones. So instead, what we're going to look at is we're going to look at a larger neighborhood that includes data that have more complicated relationships than just closest. Pi-odd, I don't know if it does both incremental and composite. But I had to build it from scratch because I was doing it on GPUs. So there are lots of different outlier detection methods in Python. There's definitely, I've seen stuff to do nearest neighbors, local outlier factor, incremental local outlier factor. I've seen stuff to do, I thought reverse nearest neighbors, but I haven't seen the full composite neighborhood before, but also this was a couple years ago. And yes, CUDA for GPUs is good. So Strawberry Jesus, the incremental is remember, we're tackling two problems with this approach. We're tackling how do we deal with streaming data? The incremental approach handles that. And how do we deal with more complicated anomalies? And the composite neighborhood tackles that.
So if you want to think about it, we had two main problems, two questions coming out of our local outlier factor, which is how do we handle streaming data, and how do we handle which is connected to the complexity, the runtime complexity. Then also, how do we handle more complicated anomalies? And so this approach combines two methods, incremental local outlier factor and using a composite neighborhood to address both of those questions. And perfectly in time, our basic local outlier factor has finished. Man, I timed that well. All right, so take this off. And PRKS Rock, thank you for following. All right, so let's compare this. And this is what I honestly found really interesting. And there's a lesson to be learned. There's a little bit of like a parable, I don't know. There's a lesson to be learned here. So let's look at, give me just 1 second here. Let's look at the most anomalous things according to our local our local outlier factor method, which is apparently Eminem and Kanye made the top 5. Hold on, what? Well, that's great. But apparently these have been considered by our local outlier factor to be the most anomalous songs. There you go. But I'm kind of curious, and this is what I found really interesting, is I think I called it ISO scores? Yeah. I called it something else, didn't I? Oh no, I just turned these into lists. That's what I did. For easier comparison. I think it's name? Yeah, it's name. All right. Let me type this out, friends, and then I'll talk about what we're doing. Those of you follow, awesome. Those of you don't, do not fear. So, looking at the top 100 most anomalous songs according to our isolation forest, and the top 100 most anomalous songs according to our local outlier factor method, let's compare them. There's only one in common. Oh no, did I not zoom in? I'm so sorry. I zoomed out so I could look at my notes. Here you go. I am so sorry. There you go. There's only one song that they both agree on that's in the top 100 most anomalous songs. And that is Have to Charge Now, Volume 4. Which, I don't know if that's famous. That is apparently by Marbletop Orchestra. There you go. And this is the weird thing, is it's J-pop, apparently according to iTunes, released 1933. Okay, whatever. I'm gonna go listen to a lot of these songs after stream, actually. All right. So, this is a lesson, though, to everybody, that these parameters that we've kind of just, put to the side, things like picking your K, which we've talked about earlier in stream, how to pick that a little bit, but also the method that you choose. Anomalies are relative-ish. And that's the difficulty, is that how we define an anomaly depends. It depends on the method. So if we have two methods that define anomalies differently, they're not going to agree on what's anomalous, not necessarily. And this is something that is a good lesson. And thank you, Bob Kagan, for following. And yes, V. Galvez, you've jumped ahead. This is why ensembles of models can be powerful. Because if you have a bunch of different methods that all measure things slightly differently, and maybe instead of saying, we're going to take a random forest approach, but instead of building individual decision trees, let's build individual models. And say, when a statistically significant percentage of our models agrees something's an anomaly, we have a greater confidence it's an anomaly. That's one way. But also it depends on your data, it depends on the shape, depends on the distribution, depends on what you expect your anomalies to look like. Do you expect them to have a certain incidence? Do you expect them to look more like very distant points in your feature space? Or are you looking for clusters within clusters? Are you looking for things that are, periodic in a time series like an exoplanet? Or are you looking for something that is just really far away? And so this is the challenge of anomaly detection. I hope that, unlike maybe with linear regression or decision trees, where maybe you walked away feeling like, yeah, I got this, anomaly detection should intimidate you a little bit. This is tough stuff, especially unsupervised. Especially. That's where it gets brutally challenging. And so to me, it gets really, really cool as well. This is where the math gets hard, the concepts get hard, but this is the space where, at least in my mind, the cool stuff happens. Not as cool as reinforcement learning, though, in my humble opinion. But, nevertheless, this is a really, really, really challenging area. And so, unlike some of the other streams where, I feel like I maybe imparted on you the answers, I just wanted to give you a lay of the land with this. So this is more about introducing you to the problem, showing you some of the approaches, but also hopefully leaving you with a sense of like, oh God, this is really complicated and difficult and challenging. And that's why things like cybersecurity or fraud detection are difficult. That's why sometimes, you get the weird email from your bank or the call being like, is this you? And you're like, yes, it's me. Why are you asking me this? Well, next time maybe have a little bit of patience, because detecting anomalies is way harder, right? When we started out at the 3.5 hours ago and I asked you what were anomalies, everybody felt so confident. They were like, yeah, it's weird stuff. It's like stuff that looks different. I could find anomalies. And now it's kind of like, what even is an anomaly? What even is data? Like, what? It gets really complicated. So, bundles of fun, though, in my humble opinion. So, with that, my friends, a slightly longer stream for tonight. So, I might actually skip the Tennessee song for tonight just because it's past his bedtime. So, he's unfortunately sleeping. And let's find somebody to raid. Also, please don't forget that, we've got some cool people here streaming. Please don't forget that tomorrow is the 30th. The hell am I doing on the 30th? Hold on. Not Switch. Just chatting. Here we go. It's about an hour longer than I usually do, but I really like this topic, okay? So I decided to give it a little bit more, a little bit longer of a time. So it looks like tomorrow we're doing, yes, reinforcement learning. All right. We're gonna introduce baby reinforcement learning. It's like reinforcement learning 101. So it'll be the basics. Let's find a cool. We could raid Sid Heresy again. He's doing that cool like music stuff. He was really, really neat. I got it. Hold on, someone followed. Thank you so much, Denatric and E5 Spartaco for following. Let's get a Smau stream. I like doing Smau streams because it makes me really happy to like raid tiny people. Because for 2.5 years, I was a very tiny stream, and I don't know. It makes me happy. Lovebone, can you also help me look for a Smau stream? Sid Heresy is kind of where I'm leaning, But we also have some other people here in the science and technology section. I don't want to look at who I'm following. Stop being weird, Twitch. God, the Twitch UI is maybe not the greatest, is it? Also, thank you for following Elven Thief. And thank you, Third Tier Gaming, for gifting a sub. Thank you 1,000,000%. Oh my goodness. That was extremely sweet of you. Let's see here. Help. It's being really slow for me. I'm sorry. I don't know why Twitch is being such a butt. Twitch. It just is not happy with me today. We will find a raid. Hold, please. Also, if you have any more questions, I have no problem answering them. So don't flee just yet. If you have more questions, I will be here for a few more minutes. While I'm looking for a cool person to raid. Come on. If you have any recommendations as well, I'm open to them. And thank you for, oh my goodness, wait, Pumpkin Days. No, you're not streaming. See, that's why it's so hard to find someone to raid. Thank you so much for subscribing, and thank you, Drop Dead Gamer, for following, and also Third Tier Gamer. Thank you for the other gift sub. Good Lord. See, I'm like, gifting a sub to Onad. Thank you. And do I plan to cover probability and statistics topics on the math days? I do. And thank you, Pumpkin Days. I really appreciate it. You all can be, yes, okay, Loafbone beat me to it. Totally follow Pumpkin Days. She's developing this really, really cute farming game. It's adorable. I don't understand what's going on, but it's really cool and inspirational as somebody who's like a total baby at learning game development. And lost interest already. Thank you for following. All right, Loafbone found us someone to raid. Oh my goodness, Onad, thank you. Hype train as we're raiding. What the heck, friends? And Goofy Lagrangian, you say, isn't the notion of distance very subjective? Yes, we talked about that in stream. If you missed it, go back and look at the VOD. We talked about how distance is subjective. And T-shirt Terry, thank you for the bits. Strawberry Jesus, you ask, what is the composite area for in the incremental method mainly? So remember that I said that method combines two things. The incremental approach, which helps us handle streaming data, and it helps us handle complex outliers. So the composite area is for handling the complex outliers. So for dealing with those clusters within clusters or processes within processes, that kind of outlier. And it is instead it's the incremental local outlier factor that I explained previously that handles the streaming data. When we smush the two together, we get the incremental composite local outlier factor method, and it handles both of our main concerns. And let's see. Can you give 23 more bits next time? I'm surprised that Loafbone didn't. Thank you for the bits though, Loafbone. Appreciated. We've got a tiny stream here, building a PC. Let's raid this stream. So please stick around. These are tiny streams. I love to raid small streams. So let's show some love and let's raid this person. Let's follow them. Let's cheer them on in building their PC, all right? And I will see you all tomorrow for reinforcement learning. So come back, please. All right? I'll see you tomorrow. Have a good night.